Everyone, good morning. Will you please welcome back to the stage Dan Galpin.
Hey, good morning, everyone. Thank you so much for getting here bright and early in the morning, for listening to us when we said things were starting a half an hour early. Welcome to everyone on the live stream and all the people who are watching in our viewing parties. So just a couple of notes about today. One is that we do not have lightning talks today. We only have 40 and 20-minute sessions, and please, try to stay for both 20-minute sessions if you can. Check the schedule one more time to make sure that you don't miss your favorite or perhaps least favorite engineer or topic at the office hours. And one more thing is, you probably noticed there was a schedule change this morning. The D8 and R8 talk is not happening because Mr. Wharton had a special project that he calls 23E, for those who are following him on Twitter, and we congratulate him on that. And so instead we'll have Trash Talk, which is a great talk with Chet and Roma happening in the other room. But the exciting part right now is that we have an esteemed group of people to be talking about the future of Android and foldable. Please welcome Andre, Adrian, and Jisun. Thank you.
Good morning, everyone. Thanks for joining us today. My name is Adrian Roos. I'm a software engineer on the Android framework team.
I'm Andre. I'm also a software engineer on Android frameworks, and I work on multi-display.
Hi, I'm Jisun from Samsung Mobile. I'm engineering director.
So by now, I'm sure you've all seen the announcement that we are partnering with Samsung to make foldables a thing on Android. And today, we're diving a bit deeper into what that means and what we're doing to support you developers with targeting foldable devices and similar form factors. And Jisun is here to talk a bit more about what Samsung is doing and share more information about their device. So with that, I'm going to hand it over to Jisun.
OK.
Thanks.
Thank you. So again, I'm Jisun from Samsung Mobile. And I'm going to talk about the new form factor device, which we actually announced yesterday at the Samsung Developer Conference at Moscone Center. OK. So I will cover more information about the device itself, and also we'll talk about the experience the new foldable device will bring to the users. We all know that the smartphone has been providing new experiences for the last 10 years. And it actually changed the way people think, act, and also communicate. Additionally, it also opened up a lot of new opportunities for the developers. Now we believe a foldable phone is one of the next game changers, which will provide a very unique experience to the users and also new opportunities for the developers to drive innovations. OK, so now let's talk about the first Samsung foldable phone. The first Samsung foldable phone is designed to be multi-display with 2 screens and also supports a multi-active window for a better experience, user experience. So let's take first a look at what the actual configuration of the display on the device looks like. So this is the main display when the device is unfolded. The main display is large enough to provide a very unique experience. With just more surface area it provides, the experience becomes richer and more immersive. The experience was hardly achievable even from the existing large screen smartphones. In addition to the richer and the immersive experience from a single large screen, true multitasking will become also available to utilize this large screen with up to 3 multi-active windows. When the phone is actually folded, we still have very useful and portable cover display to use. In this mode, the experience is very similar to your daily smartphone use. But compared to the main display, the experience is more to be focused and handy and quick interaction to actually leverage the small screen. So having said that, here are the some numbers that you may be interested in. This is the specs and the dimensions of the actual screens. So 4.58-inch cover display provides 21:9 HD plus resolution with 420 dpi screen density and 320 dp smallest width. 7.3-inch main display supports 4.2-3 QXGA plus resolution with the same 420 dpi screen density with 585 dp smallest width. These are the numbers your app may need to know. Now I will show you some expected user experience with some examples. So comparing the user experience between the existing smartphone and foldable main display, this foldable phone can actually allocate wider and larger display access to the application, and it actually enables the contents on the screen to be richer and more detailed, as you can see from this screen. On the cover screen, when device is folded, I said the experience can be optimized to provide quick and easy access and interaction, while the device is still fully functional, like a normal smartphone. Access to the quick panel or notification or call or messagings are good examples to highlight the best use of a cover display. We know that you may not want to just unfold your phone to take an incoming call. While the cover display and main display, each one provides its own very unique experience by itself, the experiences between them are not separate nor disconnected. Rather, the user experience between the displays is very continuous and connected seamlessly. As an example, if you want to search for the location of Moscone Center from a map, you can do that with your phone folded. However, if you unfold your phone, the application still continues to run. Even more, unfolding the phone actually provides more information with more visual clues, like what are nearby and what's the location to the other point of interest. Using the Gallery app is similar. The app experience continues between the folded mode and also unfolded mode. Multi-active windows for multitasking is also one of the key features of the foldable phone. So while watching a YouTube video, if you want to browse a website, you can just open a browser and browse the website while your video still keep playing. Moreover, if your friend actually sends a message and the message notification pops up, what you can do is just to grab that message and drag it to a third window, like this, to continue chatting and browsing while your video still keep playing. So we have discussed the expected experience with the new foldable device. So now Adrian from Google will talk about developer guide and also some Android platform level support to make your applications best fit for the foldables.
Thanks for sharing that, Chisun. So let's talk a bit more about how you can take advantage of foldables in your apps and kind of the guidelines that we recommend to do so. So first up is screen continuity. screen continuity is really the concept, is what we call the concept of continuing what you're currently doing after you fold or unfold the device. And in the example here, for example, you have a map you're looking at on a folded device, and you would like to see maybe a bit more about the surroundings of the place you're looking at. So as a user, you unfold the phone, and with a continuous experience, you're still looking at the same place, your state is maintained, and the phone can take now a bit more advantage of the form factor and show you more about what's going on around this place. And this is actually not really a new thing in Android, right? We've had to deal with similar situations before with things like screen rotation or changing screen sizes, or sorry, changing window sizes in multi-window. So why should you care about continuity when you build your app? Well, users unfold their devices for a reason, and usually that's because they want to dive deeper into the task they're currently doing. So that really works best when they are not interrupted in their experience when doing so and can continue where they left off before unfolding. So for a satisfying user experience, it's really important that this works well. That seems great. Now, how do you actually pull this off? Well, as I said, Android is familiar with this, and we've built a configuration change system to deal with that. Folding and unfolding the device will be treated as a configuration change in the screen size and screen layout categories. And to support you with that, the Android system by default recreates your activities when a configuration change happens. This has the advantage of taking care of any layout changes you might want to make when taking advantage of the new configuration. But it also means that you, as the app, are responsible for restoring the state the user was in after the activity is recreated. To support you with that, we have the OnSafe Instant State facility. And we're also introducing a new Jetpack library called ViewModel to support you with that. Alternatively, you could also decide to handle the configuration change yourself by just applying it and adjusting your layout. To do that, you can declare that you can handle the configuration change in your Android manifest, but that means that you'll have to manually adjust the layout to the new screen size and new configuration. And for the best experience, make sure to correctly implement multi-window and to declare your activity as resizable. Now, next up, we're making some changes to the lifecycle in multi-window. You can see the current behavior on the left, and that is that only the activity that the user last touched is in the resumed state, while all the others are in the paused state. Now, that's a bit confusing to users because it's not immediately obvious why one activity is a bit more interactive and why other activities are in a less interactive state. And it's also one more thing you have to keep in mind as a developer when you target multi-window. So to make things simpler, we're introducing multi-resume mode. In multi-resume mode, it's pretty simple, really. All the activities in multi-window that are at the top and are visible are all in the resumed state. Now, Android Pie didn't ship with this behavior originally, and so we're making this an opt-in behavior in Android Pie. It will only be applied if both the app developer opts in and the device manufacturer actually implements this feature according to our spec. But note that in future versions of Android, we are expecting to make this behavior the mandatory behavior across all apps and devices that run on the next version of Android. So let's say you have an app and want to take advantage of the simplified lifecycle. How do you opt in? Well, again, it's pretty simple. You add this one flag to your Android manifest. There's one caveat, though, because there are now multiple activities that could be resumed at the same time. It could also be that it's more than one activity from your app's process. And so be really cautious around code that stores the one resumed activity, because there might now be more than one of those. And also be cautious around libraries and frameworks that might make the same assumptions. And with that, I'm going to hand it back over to Andri, who's going to talk about multi-window, multi-display.
Thank you, Adrian. So let's talk a bit more about multi-screen devices. So as you know, starting with Android O, an activity can be launched on a non-default display. Let's see what it actually means for your activity. First of all, when an activity is on a non-default display, it means that the activity context, which is a visible entity, is different from non-visual application context, also available from broadcast receivers and content providers. The context of a visible entity will be always adjusted for the display area where it is shown. For example, if you use the same API to get the current display and use different context types to ask for it, you will get different results. The current display, you can get it from the activity, and the application context will always give you the default display. Different contexts also mean different resources and configurations. They will be automatically updated for you. All you need to do is just to request them from the correct context. Usually, when you want to adjust your UX for metrics of the currently available screen area, you should be using an activity. Keep in mind that a user may move your activity from one screen to another at any point. In most cases, you can expect displays to have different sizes, densities, and resolutions. This means that an activity that was moved will probably get a configuration change, as Adrian has covered before. And if it declared to handle the change, it will be notified with a new config. If not, it will be relaunched. To deliver the best possible experience, both for foldable and for multi-display devices, we really encourage you to handle configuration changes whenever it's possible. And if your app really needs to know what display it is currently on, you can check in onCreate and onConfiguration change. These are good points to do that. So what if you want to take advantage of these additional screens? How do you use them? So the first step is to actually get the list of all displays that are available in the system by checking with Display Manager. The displays will have many different characteristics. So you can check their flags, metrics, and state to find the one that suits your needs. For example, you can look for a large screen to present your media content or filter out the displays that are currently off. Once you have determined what display you want to use, you can launch your activity there using this Activity Options API available in Android O. Remember that all existing intent resolution and launch mode rules still apply. So for example, if you want a new instance of an activity, you may want to use corresponding flags in Android Manifest to allow multiple instances and use new task for this launch. Sometimes the system may restrict activity launches to some certain displays, for example, private displays. In this case, a call to start an activity will throw a security exception. You can expect this and wrap the start with try catch. Remember that there are several platforms that actually have multi-display devices. Phones with different screen configurations is just one example that we have covered today. Next, there is desktop mode, when you connect your phone to a larger screen for improved productivity or entertainment. Another example is Android apps running on Chrome OS. In both of these cases, the apps are usually running in freeform windowing mode, and the user expects them to be freely and smoothly resizable. Last but not least is automotive Android. There may be many screens in a car, and multiple users may be interacting with different displays at the same time. For example, kids in the back seats may be playing same or different games while the driver is using navigation. For apps in general, there shouldn't be too many differences on what platform it's running on. To verify your app behavior, on any Android device running O or above, you can create a simulated display through developer options and launch your activity there. Unfortunately, at this moment, simulated display does not handle touch. We are working on improving this experience in the upcoming releases, and we are going to be adding new developer tools. With all these new and existing platforms, you can choose to simply optimize your app or build some unique multi-screen experience. You can decide whether you want to support multiple activity instances, test your app, and set corresponding launch modes. Don't forget that in this case, multiple activities may be focused and receive user input at the same time. Also, consider using a shared source of data with multiple view models in your app and take advantage of other architecture components. With that, back to Adrian.
Thanks, Henry. So we've talked about what's available today. Let's also look a bit more about what we're going to do in the future to support you with targeting foldables and multi-display devices. In the short term, this applies mostly for Android Pie, we're working on developer guidelines, and we're going to show you how to best target foldables and multi-display devices. We're also working on a blog post that's going to go live in the following days, which will have more information about everything we talked about. And we're also working with Samsung to release an emulator where you can develop and test your apps against the configuration change behaviors and the multi-resume behaviors that their device is going to have. Looking a bit more into the future, with future versions of Android, we're implementing support in AOSP for foldables and multi-display devices. And as part of this, we're also going to improve the AOSP emulator, so it will have support for simulating all those foldable and multi-display behaviors, as Andrei also mentioned. Finally, some pointers on where you can find more information. In the following days, as I mentioned, we'll have this blog post up. There's also a Samsung developer site where you will find more information about Samsung's devices and their guidelines. And for testing your apps, the Samsung emulator will also be available on their website sometime in Q4. OK. At this point, I would also like to thank you for all the amazing experiences you developers are building for Android. And we're really excited to see what you will do next and what you will create next on this new form factor of foldable devices. Thank you. If you have any questions, we'll be in the Q&A.
Good morning. I'm Chris,
I'm Alan.
and we're here today to talk about the cost of a pixel, specifically the colors that you choose in your apps and how they directly affect the battery uses of your users' devices. So before we do that, we need to think about the actual technology that goes into users' devices, and specifically the display technologies. Now, there are two prevailing kind of technologies that are in most devices, LCD and OLED. The majority of devices, especially on Android these days, tend to be OLED devices, OLED screens, especially from the mid-level to kind of high level. And even in sort of like other platforms, they're slowly moving to OLED as well. LCD stands for liquid crystal display, and they work very differently to an OLED. They work with what they call liquid crystals. So each pixel will be made up of a number of color channels of liquid crystals. The important thing to know here is that they require a backlight. So those liquid crystals don't illuminate themselves. It requires a backlight behind it to shine through the crystals, and that's how you see color. Now, most of the power for an LCD display goes into that backlight. The actual crystals don't require that much. It's the backlight. So more brightness is more power. OLED are different. OLED displays are light-emitting diodes, which, as you can guess, actually emit light themselves. So there's no need for a backlight. Each pixel will illuminate itself, and that's how the light shines out. The good thing here is that they allow a true black. So with LCD, the way you achieve black is by turning all the crystals on, and then the backlight still shines through. So you can never really get that really dark, true black. OLED's completely different in that the way that LEDs work is they just don't turn the pixel on, and that's how you get black. So that's where the power is. And the power is dominated by actually emitting the light. So it's the LED shining that actually is the power. There's no backlight, it's the actual LED itself. Now, there's a number of kind of arrangements that displays can be made in. So if you think about a pixel, you tend to have 3 channels, R, G, and B. And that's the simplest arrangement. Each pixel on your display will have 3 channels. And that is true for both LCD and OLED. Both can have different arrangements. So that's the most straightforward and mentally simple, like you have 1, 2, 3. But there's also more complex ones, things like RGBR, where all the channels will be split across 2 pixels. And each pixel will only have 2 channels. It's just a way of kind of expanding pixel size without trying to fit as many LEDs in. Now, it's important to think about because in terms of power, more LEDs equals more power usage. So we've done a lot of stats over the past kind of year or two because we know that users care deeply about their battery life, and the display tends to be the biggest power user of your device. So here you can see a very straightforward chart, which is the fact that the higher the brightness on your display, the more power it uses. And, it's kind of simple anyway. Like everyone assumes this is the case. But the thing is, it's actually quite linear. So again, kind of simple. But then we started kind of comparing OLED devices, OLED screens versus LCD screens. And in this case, it's the Pixel versus the iPhone 7. We were displaying a screenshot of maps in both a normal day mode and a night mode. The reason we use a screenshot is because we didn't want the differences between, say, iOS or Android to conflict with the power. And displaying a screenshot is just displaying an image, so they should be pretty similar on both platforms. But you can see with the numbers that the iPhone 7 and the LCD screen, the actual milliamperage on both night and day is the same. It doesn't change. And that's because it's an LCD screen, and it can't make use of those dark pixels. Well, the power uses anyway. But on the Pixel itself, because it's an OLED display, the actual power usage drops down by 63%, which is huge. Like 63% of the biggest power user on your device, just by using a dark theme. But even going more into it, when you look at actual individual pixel colors, so we did a test where we just displayed one color on the display. And the actual color itself makes a big difference in power. So blue itself is 25% more, takes 25% more power than, say, green or red. And then another chart, which is pretty much a summary of the previous chart, but it's in nice line format. But you can see that black uses the least amount of power, kind of assume it anyway, and it goes up and up until we get white. And because white needs channels from everyone, it's full red, full green, full blue, it requires the most amount of power. And guess which color we've been pushing you towards over the past couple of years? Material came about, whatever it was, 3 years ago, and we changed from hollow, which was a nice dark theme, to this white theme instead. And we kind of shot ourselves in the foot slightly in terms of power. So let's look at some case studies of Google Apps over the past year or so, actually, which have started implementing dark themes and the power savings they've managed to have. So the first one is YouTube. Here we have an example which, you can't see the video playing, but it is. And you can see that at full brightness, just by switching to a dark theme, you save 43% of your battery usage. Now, when you're playing a video, the rest of it underneath isn't so important anyway, so dark theme really works. Now, when it's paused, we save even more. It's 60%. My guess here is that because the kind of overlay of the video actually darkens the video, we're using even more dark colors, so we save more power. Now, this test itself depends very much on the video content. If you have a video which is fully white, then you're not going to save so much. And with Gboard, so Gboard's actually a really good example because this is something users can control. You can switch to a dark theme, and you can save 20% of your battery. Well, not 20% of the display use of the battery, just by switching to a dark theme. So it's actually quite a big thing. And finally, on maps. This is kind of the canonical example of dark theme and where it really is great. Because it has the obvious benefits of the battery, which is 31% when it's on full brightness. But it's also usable. Like, you don't want maps being a really white theme when you're driving at night and glaring you in the eye. So dark theme here really makes the app more usable in a nighttime setting. And now Alan's going to talk about implementation.
All right, so how can we embrace the dark side and implement dark mode in our apps? We'll go into dark theme, which will not save us any battery here, but it will on your devices. So you may remember night mode from the developer preview of Android last year, or the year before that, or the year before that, or the year before that. But we released day-night support in AppCompat, which was implemented by Chris. There's a great blog article about it. Our recommended way to implement dark mode in your app and basically get it for free, depending on how your themes are architected, is day-night. So if you're using AppCompat, you can get this almost for free. The stock widgets will respond automatically to changes in the device's night mode. You can also manually toggle between light and dark modes. So you can add a switch in your app to do this. This is the demo from the Android X checkout. If you have Android X checked out from AOSP, it takes 5 minutes. You can run the AppCompat demo and take a look at how this is implemented. It's basically one line of code to switch between whatever theme you were using before and AppCompat. You simply take whatever your app theme is and have it inherit from one of the AppCompat.daynight themes. And again, depending on how your app is architected, everything might just work. You can also apply an overlay theme dynamically at runtime. So if you want to have a pure black OLED themes, there are some apps that already do this, or a pink Hello Kitty theme, or what have you. You can apply a theme dynamically at runtime by just calling getTheme.applyStyle and applying an overlay theme. If you want to learn more about overlay themes, Chris and I talked about those at I/O a couple of years ago. So what that looks like is just overriding activity.setTheme. This ensures that any time a theme is set on your activity, you will then immediately overlay it with the black theme or Hello Kitty theme or what have you, and then any views that get inflated will be using that theme correctly. All right, either way, you're going to want to structure your app to rely on theme attributes. When I said depending on how your app is architected, this is what I'm referring to. All of the platform drawables heavily rely on theme attributes to obtain their colors. So things like color foreground, color control normal, color accent you've probably seen. The implementation of the material track switch, the switch that you can drag left and right, the thing that sits directly under that is colored light gray when it's enabled, and dark gray when it's disabled. The implementation of that is just a color selector, a color state list that refers to the color foreground attribute from the theme, which is white under a light theme, black under a dark theme, and a disabled alpha, which is also defined by the theme. So we vary that based on light and dark themes. You'll notice there are no colors hard-coded here. And in general, you don't want to hard-code colors. We'll talk about this more later today in a talk with Nick Butcher about themes and styles. Right, so I mentioned night mode showed up a couple of releases ago. The night qualifier has been in the platform since SDK 8. It has always been there. It was opened up for general use in Android N. So the ability to set the night qualifier system-wide. There are some apps now that accidentally set the night qualifier system-wide. If anybody noticed messages doing that recently, it's been fixed.
Tell them, Alan.
This is what you'll use for switching your resources. It's a resource qualifier similar to portrait or landscape. You just create a drawable-night or a values-night. And if you have resources that are difficult to extract theme colors out of, say you have a welcome splash image that is very complicated and you couldn't put it in a vector drawable, so your designer just gave you a PNG. And you can get a dark version of that that has significantly different colors, and it's too complicated to put in a vector drawable. You can just drop an alternate version of it in Drawable Night. When the device is in night mode, or when your app is in the AppCompat implementation of night mode, you'll pick up that drawable automatically. Same thing for colors. If there are colors that you want to switch, say your accent color is slightly brighter in a dark mode, you can extract that out to a named color resource, have one version in colors, one version in colors night. Values night. All right, so here's what the theme implementation can look like. If you want to switch your parent theme based on night qualifier, you simply define the theme twice, once in values night, and give it a different parent. When your theme is referenced under non-night mode, you'll pick up the light theme. When it's referenced under night mode, when the night qualifier is on, you will pick up the dark theme. Same thing goes for colors. So here we just have the same color defined two different ways. Anytime that you reference hard-coded FG, it will pick up black under non-night mode. It would pick up white in night mode. All right, so what can you do to update your app, maybe do a little bit of restructuring, and make it work really well for night mode? Well, you can start really simple. Just take a screenshot of your app, invert it, see how it looks. Get a sense of whether there are images that you'll need to have an alternate version of. Here we see a bunch of avatars. Those we probably want to keep the exact same. Maybe we want to change the background colors a little bit. So that may mean extracting theme attributes. That may mean creating some alternate values if they're vector drawables. Or that may mean getting different sets of PNGs to drop into Drawables Night. Next, you want to take a survey of the usage of colors in your layout XML and in your styles. So go ahead and set the parent of your theme, whatever your app or activity theme is, to be something dark, theme.appcompat or theme.material, and see how it works. You'll want to look for issues with losing contrast between foreground and background, not seeing dark colors where you expect to see dark colors, and in general, what you see should look a little bit like that inverted screenshot. You'll notice here, it looks nothing like the inverted screenshot because all of the background colors and foreground colors were hard-coded to be light theme. The one thing that wasn't hard-coded, and you can almost see it here, is the label for first name, which is now invisible because it's the only thing that's correctly pulling in the dark theme color attributes. So this is going to require a lot of work. The hard part is doing that work. So you'll want to refactor your colors as much as possible. Take any hard-coded colors in your layout XMLs, move those out to named color resources. You can split those based on values night. If you want to do more than one type of theme, maybe you have a Hello Kitty theme that you want to apply dynamically, you want to extract those to color attributes that have some sort of meaning in your application. So as I mentioned before, we have text color primary that's built into the platform theme. We have color accent. We have color primary. So you should be using those as much as possible and certainly take advantage of theme attributes for specifying colors, propagating those into your drawables, into color state lists, into your layouts. You can convert colored PNGs to alpha masks and use tinting. If you look at we don't have a slide for that. So you can wrap those with a bitmap element and set an alpha and set a tint with Android:tint. We'll talk, again, a little bit more about this at the Themes and Styles talk later today. All right, next, you actually move over to the AppCompat day-night theme, and you get automatic switching when the device is in night mode. You could also consider adding a preference. So here we have the Twitter app. I don't use Twitter so much. The Twitter app, which has a very obvious affordance for switching between day and night. So if you tap this, it goes into dark mode, and it's really convenient for your users. You'll also want to keep in mind that there is a platform-specified dark mode, so you may end up with a tri-state that says inherit from the platform dark mode, or I can specify always dark or always light. You'll also want to test that your application works when night mode changes. So you can toggle this manually using ADB from the command line. So open up your app once you've implemented the day-night theme. Toggle it into night yes. Your application should preserve whatever state you had and be recreated. It's going to go through a full on-destroy and recreation and be recreated in dark theme, preserving user data. On Pixel 3 devices running P, night mode will automatically switch when the device enters battery saver mode. So that's another way that you can test this. You can also toggle it directly from developer options and push night mode to be always on, always off, or one of the legacy things that we support is switching based on time of day. You can also learn more, as I've mentioned many times, in the Themes and Styles talk that I'll be giving with Nick Butcher later today. If you want to learn more about the lower level things in Themes and Styles, Chris and I gave a great talk a couple of years ago at Google I/O. So that covers everything you want to know but have been afraid to ask about Themes and Styles. And if there are things you're not afraid to ask, we will be outside in the Android Lounge that way to answer any of your questions. So thanks, everybody, for coming. Please embrace the dark side.
Hello, good morning, everyone. Welcome to Improving Battery Life with Restrictions. My name is Jing Yu. I'm a developer advocate from the Partner DevRel team.
Hi, I'm Amit. I'm a software engineer on the Android framework team.
So today, we want to start with this notification that we've all received, hopefully never around this time of the day. Knowing that our battery is running out can be really frustrating and sometimes scary, depending on where we are and what we're doing at that time. These days, we rely so much on our devices for navigation, talking to our friends and family, taking pictures, and even translate for us when we're traveling in a foreign country. But all these cool features and amazing apps that you built cannot help the user if their battery is dead. So that's why today we're talking about how we're going to improve battery with your help, hopefully. And this is what we're going to cover. First, we'll talk about what's consuming power and how we measure power consumption. And then we're going to go through the power-saving features we introduced in recent years. And in the end, we're going to talk about how your app will be affected by these restrictions and what you can do to work with them. Next, I'll pass it over to Amit to talk about what's consuming power.
Hi. Quickly walk through how we actually estimate how an app consumes power, how much power it's consuming on the device. These are the typical components, hardware components that are consuming power on a typical phone. I've highlighted some of the top consumers. You got an earful about display and how much power that consumes from Chris and Alan. Running the CPU at high frequencies is also pretty expensive. And transferring data over the cell network is quite expensive as well. So when each device is manufactured, the OEM provides something called a power profile. What the power profile contains is the average current drawn by various subsystems that we want to measure in real time. For example, if you turn the screen on at minimum brightness, it might be about 100 milliamps. And if you crank it up to full brightness, depending on the technology, let's say it adds another 300 milliamps. So we keep track of that in real time. CPU at different frequencies has different power consumption, so we have that in the power profile as well. At runtime, what we do is that there's a subsystem called battery stats. It tracks what each app is doing. It measures how long it's consuming each of these resources, like how much CPU time, at what frequency, how many data packets it's transferring, and so on. We take those values and then we multiply with the power cost for each of those in the power profile, and we get an approximate estimate of how many milliamp hours the particular app has drained. And then we rank all the different apps based on their consumption, presented to the user, so they can see that in settings, and then they can learn for themselves what's really draining their battery. So let's talk about how the OS is trying to help the user extend their battery life. But first, broadly speaking, there are two reasons why an app runs. Right? The user's launching it, it's running in the foreground, users actively using the app. Now, as developers, that's something you don't want them to not do. But that's a whole different topic about digital well-being and trying to help users control how much time they spend on apps. But one note I want to leave about that here, because we're not going to talk too much about it, is there's a concept about suspending apps, and that's something you might want to read about, and how that impacts your app if the user suspends the app for, say, the rest of the day. But we'll focus on how we try to limit background activity from an app. An app can schedule background work by using jobs or alarms or setting up a background service. It can also register for callbacks for external triggers, such as a push message or you walking past a geofence. So over the years, we've introduced several features in the OS to save battery. First, in Marshmallow, we introduced doze or deep doze. As the name suggests, it puts the device into a really deep sleep under the condition that the device is not moving. So let's say you left it on your desk or on your nightstand, you forgot to plug it in. It basically shuts down a lot of the background activity so that you can really extend your battery life. But this is not really how we use our daily phones, right? We are walking around with it, we're using it throughout the day. So we came up with doze on the go, or light doze. What that does is it puts the device into a slightly lighter sleep and wakes up more frequently so that it has an opportunity to see if there's any pending work to do, so that your data is reasonably fresh. But it's not in front of you, you're not using the screen, so it can shut down some of the background work. You're probably all familiar with the Oreo restrictions on background services, as well as limiting the number of implicit broadcasts that you can wake up to. And as of this month, everyone needs to target Android Oreo or above, because otherwise you can't publish to the Play Store. But we'll focus more on what's new in P, adaptive battery, app restrictions or background restrictions, and we've also made some improvements to battery saver. Adaptive battery is actually an evolution of App Standby that was introduced back in Marshmallow along with Doze. What App Standby did was put apps into two possible states, active or inactive, based on usage. Adaptive battery extends this into 4 buckets now, where active is the least restrictive, and based on usage, we move it into some of the other buckets, and rare is the most restrictive. For instance, if you were at Google I/O and you install the I/O app, by now it should have gone to the rare bucket because you haven't been using it. So how does the OS assign these buckets to each app? It starts off when you're installing the app in a never bucket. It's not shown here. It's really not that relevant. But once you launch the app, or every time you launch the app, or any kind of strong interaction, like clicking on a notification from the app goes into the active bucket. And it stays there for a while, and maybe in a few hours, it comes down to the working set, where it starts applying restrictions on what you can do in the background. And then a little later moves to frequent, and then to rare, and then we uninstall your app. I'm just kidding. We don't do that. And if there's some kind of an indirect interaction, such as you're looking at a notification by pulling down the shade, it's not a clear indication that it's an active usage of the app. So we put it in a slightly restricted state, which is the working set. What is actually adaptive about this is if the device happens to have a machine learning algorithm, what it does is it watches your usage patterns, learns over time, and then it decides, OK, this app is probably going to be used in the next couple of hours. Let me put it in the active set, and maybe it can freshen up its data. Maybe it needs to download the latest news or whatever. And once it feels that maybe the app is not going to be used for a while, it might move it into one of the lower buckets. So this actually really improves our ability to reduce the amount of work that apps do in the background. And it's not your fault. It's just you don't know how when the user is going to launch you, so we're trying to help with that. App restrictions is another feature, which is kind of an extreme version of background limits. We really limit what the app can do in the background. So it's mostly meant for apps that you just want to be doing work in the foreground. Right? There are two ways the app can go into this state. The user might see in settings that your app is draining battery and decides to manually restrict the app. The other way is the system is monitoring certain criteria about how the app is behaving. And if it feels that it's doing anything excessive over certain thresholds that we set, it suggests to the user, hey, do you want to restrict this app because it is draining your battery in the background? These are things that we will improve over time, the kind of criteria and the thresholds. And OEMs are also free to add their own criteria. So what is restricted? If an app is background restricted, the usual jobs, alarms, foreground services. You can't run a foreground service if your app is in a restricted state, because as far as the user is concerned, it is still kind of a background thing if you see something happening with a notification and it's doing work in the background. FCM, as of January, will be restricted as well, so you won't get any messages when your app is in the restricted state. You also don't get location updates. And one thing that's unique about app restrictions is even while the device is charging, we don't let you run in the background. This is not true for any of the other restrictions. And the reason is this is not just about saving battery, it's also about annoyances and maybe privacy concerns. Battery saver was improved in Pi as well. It's very similar to how app restrictions work, but it applies it across all the apps. Some of the differences are foreground services are OK to run while in battery saver, because you might want to be listening to music while on battery saver. There are no restrictions on push messages. Network is restricted, jobs and alarms, the usual ones. And one thing that's new in Pi is we turn off location services completely, at least on Pixel devices. OEMs might not choose to do that. So we have some APIs that you can use to detect which state you are in, which restricted state. For example, you can ask usage stats, what is your current standby bucket at this moment? But if you want to debug something or want to know how frequently you're in some rare bucket, you can also get historical information about your standby bucket changes. You can also check if you're background restricted right now, and maybe you want to tell the user something about that, or maybe your critical services will not work. But please don't nag the user. If they don't want you to run, they don't want you to run. And you can also check if battery saver is on. Internally, it's called power saver mode. Hand it back to Jingyu.
Thank you, Amit. So how is your app affected? So anytime to the system, your app will be in one of these two states. It will be either in the foreground or the background. And whenever your app is considered to be in foreground, all these restrictions are lifted, so you can run whenever you need to. But when your app is in background and the device is not charging, all of the battery saver features that Amit just talked about, any of them could be enabled, which means that your jobs, alarms, network access, and FCM messages could be restricted. And next, we have some really beautiful diagrams which will show you how they are affected. First, let's look at the scheduled jobs. given that all the constraints you have on the job is satisfied. These are the features which will affect when this job will get run. First, let's look at the device level. If the device is in DOS, then your job will be deferred to maintenance window. And then if user decide to turn on battery saver or app restrictions, meaning restrict your app from that battery setting, your job will be deferred until user opens the app or when the app is in foreground. And if none of those are true, then it's up to app standby bucket or adaptive battery in Pixel. Your job could be deferred up to 24 hours. That's when your app belongs to the rare bucket, and that's the worst case, which means that even in the worst case, your job will still get run every day. So similarly, for Alarm Manager alarms, these features will affect when your alarms fire. When device is in DOS, your alarm will be deferred to maintenance window. And if the user turn on battery saver or they restrict your app, your alarm will be deferred until your app is in foreground. And finally, to the app standby bucket, your alarm could be delayed until up to 2 hours if your app belongs to that rare bucket. So if your use case really requires that exact time execution, then, for example, like if you want to remind the user they need to take medicine or a TV program that they subscribe to is about to start. So for these use cases, you can use this site while idle method that we provided, so your alarm will fire on time. But when you are using Alarm Manager to wake up the device frequently, and imagine that if every app is doing that at a different time, then you are draining a lot of battery. That's why we have the excessive wake up on your Android Vitals page. So if you see your excessive wake up on Vitals page is caused by Alarm Manager, I would highly recommend that you think about maybe it's time for you to migrate to some other APIs, like Job Scheduler. If you're sending push notifications, you're probably already using Firebase Cloud Messaging. And similarly, your FCM messages will also be affected. When the device is in DOS, your normal priority messages will be deferred to the maintenance window, which means that if you're sending high priority message, that message will be delivered immediately. This is because high-priority FCM message, they are created to trigger action that's visible to the user, like sending a notification, so user can act on it. And if the user turn on battery saver, then still your messages will be delivered as it is. As Amiss mentioned earlier, if the user restricted your app, currently, the messages are still delivered, but as of January next year, 2019, all these messages will be discarded because this is a strong signal from the user that they want to restrict the app. And finally, in the app standby bucket, there's a different cap on each bucket that your app could belong to. The more active the bucket is, the more high-priority message you can send. But if you reach that quota, don't worry, we're not discarding your message. We're just downgrading them to normal priority, which means that they could be delayed a little bit when device is in DOS. So if you really want to reach your user with that important message, don't use high priority for operations that don't require user interaction. Whenever you're sending high priority, it should trigger a notification or something user can interact with. OK, here's a summary of the power-saving features that we talked today. One thing to note is that all of these features we see here, they will apply on any app that's running on Android 9 device, no matter which target SDK you are targeting. So our first advice to you is please test your app against all of these features. We have ADB command on the developer doc you can use to put your app in all of these features and test your use cases to see if your push notifications are coming through, if your job is running, are you handling that case well? The good news is, except for the high-priority FCM message restriction that I just mentioned, all actually, none of the other restrictions is new. We had them since DOS. So if your app works well under DOS, it's very likely that you don't need to change much to work with these features. Our second advice to you is whenever you're running tasks in the background, please keep in mind to use this lazy-first design principle. Try to reduce the work you're running in the background. Think about, do I really need to run in the background? Can this wait till my app is in foreground? And think about, do I need to run with this frequency? Maybe reduce some work I'm doing in the background. And if you really need to run in the background, try to defer that work to a later time, say when device is plugged in, or think about that exact alarm. Does it have to happen at that exact time? Can it wait? And finally, try to coalesce the work you do in the background. So in Lollipop, we introduced Job Scheduler, which is a way for you to help the system to intelligently batch all the background work. And this year, we introduced Work Manager in Jetpack, which makes running background work easier. And since when it hits stable, it will be the recommended way to do background work. So with that in mind, let's look at this upgraded view of how you do things in the background. If you're running a work, if you need to execute a work or do a sync that's deferrable locally, then Work Manager is your answer. If this work is triggered online, then you would use a FCM message with Work Manager, meaning you would want to use FCM message to notify your app that there's some work you need to do or you need to sync with the app server, and then in the message handler, you enqueue that work. If your use case doesn't fit with either of these cases, and you need to run something at that exact time, then you would want to use Alarm Manager. Finally, if this is something that the user started, user is aware that it's running, and it must happen immediately right now, then you would use foreground service. But please, whenever you're using this foreground service, add that action in the notification, because there's nothing more frustrating than seeing a bunch of notifications, but there's nothing I can do about them. Because foreground service notification, you cannot dismiss them. So please add that action in the notification for user to stop their service, and then notification is dismissed. And if you reach the end, I would say go back to the top, or you should wait until your app is in foreground. So we have a Work Manager talk later today at 1 p.m. Please go to that to learn how you can use Work Manager to do background work. And we also have a lot of best practices and guidance on how you can help us to help users save battery in this Power Block series. Please visit to learn more. And we will be in the office hours this afternoon for any questions. Thank you.
Thank you.
Everyone, the next session in this room will begin in 10 minutes. Thank you.
Android Go edition last year.
At Google I/O 2017, we opened the door to Room, a persistent library that provides an abstraction layer over SQLite. Now, Room has reached version 2.0 and is part of Jetpack. We fixed the bugs you reported and added some of the features you asked for. Let's go over Room's main components and see what queries are supported, how to handle migrations, and how to test your work with the database. Let's say that you want to have a table of users, and you want every row of that table to be an instance of the user class. Annotate your class with that entity. Define the table name if you don't want to use the name of the class as table name. Set the mandatory primary key and the optional column info, but only if you want to change the name of the column. Otherwise, the field name is used. And that's it. That will take care of the creation of the user table for you. So that's how the entity is done. But we need a way to access the data in the database. We do that with data access objects, DAOs for short. More precisely, create an interface, annotated with @DAO. In this interface, declare all the methods needed to work with the database, annotating them with the corresponding SQL query. Room takes care of implementing these methods for you. The supported queries are insert, update, delete, query, and raw query. All of them, except raw query, are checked at compile time, which means that if you write an invalid query, you'll find this out immediately. The class that puts together the entities and the DAOs is the Room database. Create an abstract class that extends the Room database. Annotate it, declare the entities and the corresponding DAOs. Let's take a closer look at the queries. The return type of query and raw query can be the entire entity, but also a subset of its fields. If you're working with Guava or with optional from the Java util package, you can also use them as return types. So this means that if there are no values to satisfy your query, then your query will return optional.empty or optional.absent, depending on which optional you're working with. All of these queries are synchronous, meaning that they will be run on the same thread you are triggering them from. Room ensures you follow best practices by throwing an error if you run queries on the main thread. So use your preferred method of handling threads in Android and make sure you're off the main thread. Room also supports asynchronous query when working with live data or RxJava. What's more, the queries that return live data or flowable are observable queries, meaning that you will get notified every time the data in the table or tables updates. Whenever you alter your database schema, either because you added or renamed a column or a table, you need to tell the database how to handle that change. In order to do that, in your database class, you'll need to first, update your database version. Second, implement a migration class, which defines how to handle the migration from the old schema to the new. And then thirdly, add that migration class as a parameter to the database field. After triggering the migrations, Room validates the schema for you to ensure that the migration was done correctly. If you don't want to handle migrations and you don't need to preserve your database data, fall back to destructive migrations when building the database. To destructively recreate the database only from a specific version of, fall back to destructive migration from, and provide a number for that version. So we have our entities, DAOs, database, and migrations. How do we test them? To test the DAOs, you'll need to implement an Android JUnit test that creates an in-memory database. The in-memory database holds the data only for as long as the process is alive, meaning that after every test, the database is destroyed. To test asynchronous queries, use an instant task executor rule to execute each task synchronously. In your app's implementation, you'll end up referencing the DAOs in other classes. To unit test those classes, just lock the DAO or implement the fake version. Here's another tip. To implement espresso tests, covering code that uses asynchronous queries, extend the counting task executor rule to count the tasks as they start and finish. Finally, don't forget to test the migrations. Export the database schema first and then use another handy test rule, the migration test helper. This class allows you to create a database in an older version and run and validate these migrations. All you need to do is check that the data you inserted in the older version is also present after the migration. Okay, so let's summarize this. Let's boilerplate code, compile time check queries, ease of implementing migrations, a high degree of testability, and checks for keeping the database work away from the main part. All of these qualities of Room make it easier and more pleasant to work with databases, helping you deliver better apps.
It's best practice to provide resources for supporting all devices. But sometimes it might seem like you need to make a trade-off between supporting devices and a small APK. Now, if you're not using multi-APK, supporting different screen densities, CPU architectures, and language could account for a pretty big chunk of your app's APK size. That's why we've introduced a new publishing format called the Android App Bundle. It'll mean smaller downloads for your audience and easier artifact management in the Play console for you. An app bundle is a single comprehensive build artifact that you upload to Google Play instead of an APK. Compared to multi-APK, an app bundle delivers smaller apps to users and is simpler to manage because it's only one build artifact. When Google Play has your app bundle, it uses a new process for delivering APKs called dynamic delivery. Put simply, it only sends the portions of your app that each user needs. Now, just using the new app bundle format will automatically give your users APKs with only the language, screen density, and ABI resources that they require. And it requires no code refactoring from you. Building an app bundle is just a matter of selecting the right build output. When using Android Studio, here you'll see the option to generate a signed app bundle. Select building a bundle instead of an APK, provide your key, choose the destination folder, and you're done. You'll then have your shiny new app bundle. You'll also need to enroll in Google Play App Signing in the Play console. Google Play is essentially generating optimized APKs for your users, so you need to give it the ability to sign those APKs for you. App bundles are supported by Google Play right now. The technology that Play uses to generate APKs from the bundle is open source, so in the future, your app bundle will work with other app stores that enable support. Bundles work for all devices. Devices running Lollipop and higher get the greatest size benefit from dynamic delivery, but pre-Lollipop devices will still get a multi-APK style APK, which is automatically generated by Google Play from your app bundle. Let's go ahead and take a closer look at how Google Play actually uses this bundle, what dynamic delivery is doing, and how users get their APKs. In the past, you'd upload an APK, and then Play would then serve that same APK. When you upload an app bundle, Google Play takes that bundle and splits it into multiple smaller APKs, known as split APKs. The part of the app which is always downloaded is placed into a split APK called the base APK. When using a bundle, Play automatically makes split APKs for resources, assets, and native libraries. These resource-specific split APKs are called configuration APKs. Let's take a look at an example. I'm an English-speaking user on a Pixel 2 XL with 560 dpi resolution running on an ARM64 processor. If I install your app, Dynamic Delivery will find just the split APKs that I specifically need. These split APKs will be delivered down to compatible devices and behave like a single, customized APK that's optimized for my device. For earlier devices, Dynamic Delivery will send down a multi-APK with resource-appropriate ABI and density resources. With the introduction of the Android App Bundle and Dynamic Delivery, we're allowing for automatically smaller apps and a smoother deployment process. In addition, the app bundle format also introduces dynamic features, released in beta. Dynamic features allow you to modularize specific features and then deliver them to your users on demand. For more information, check out the links below. If you're curious about bundleifying your app, the best place to get started is g.co Android App Bundle. Happy coding!
Say hello to Android Things 1.0, Google's managed operating system for building and maintaining Internet of Things devices at scale. I'm Wayne Pekarsky, and today I'm going to explain what's new in version 1.0, how it provides long-term support for production devices, and a new lineup of system-on-module hardware. So what is Android Things? Android Things is Google's managed operating system that enables you to build and maintain Internet of Things devices at scale. We provide a robust platform that does the heavy lifting with certified hardware, rich developer APIs, and secure managed software updates using Google's backend infrastructure, so you can focus on building your product. Version 1.0 is the first release of Android Things that is ready for your production devices. We just recently completed our developer preview, and the Preview SDK was downloaded over 100,000 times. Developer feedback and engagement has been critical in our journey towards 1.0, and we're grateful to the over 10,000 developers who've provided us feedback through filing bugs, attending events, and posting in our communities. A core part of our IoT platform is the supported hardware, based on a system on module or SOM design. So what is this? A SOM is a fully integrated component with CPU, memory, Wi-Fi, Bluetooth, and flash storage that you can just drop into your final design, just like you would use a library when writing software. The SOM is certified by Google, and we provide a board support package that includes the kernel, drivers, and libraries to support Android. With Android Things 1.0, we've announced support for SOMs based on designs from NXP, Qualcomm, and MediaTek. And these modules are certified for production use and available in quantities to make real consumer products. If you want to try Android Things right now without buying a SOM, you can even use any one of our developer platforms, even the Raspberry Pi 3. And this highlights an important feature of Android Things. It's quick and easy for prototyping, and when you're ready for production, there's a clear path to buying SOMs in small or large quantities, depending on your needs, and then your software is ready to go. You can then design your own printed circuit board, or PCB, to connect your hardware to the SOM. When building IoT devices, maintaining security is very important. Providing timely software updates over the air, or OTA, is a fundamental part of that. And stability fixes and security patches are supported on production hardware platforms, and automatic updates are enabled for all devices by default. For each Android Things version, Google will offer free stability fixes and security patches for 3 years, with additional options for extended support. Even after the official support window ends, you'll still be able to continue to push app updates to your devices. You use the Android Things console to upload Android APKs with your updates, so the OTA mechanism can push them out to your devices. You can initially experiment with 100 active devices for non-commercial use. When you're ready for mass production, we'll provide you with a distribution agreement, and now you're ready to sell your devices in large quantities to the public. With Android Things, you can build apps using the rich framework provided by the Android SDK and Google Play services, including the same UI toolkit, multimedia support, and connectivity APIs used by mobile developers today. You can also easily integrate your apps with popular Google services like Firebase, TensorFlow, and Cloud IoT Core. This is done using the many existing Android client libraries. And since it's Android, you can use Android Studio and all of its languages and tools right out of the box. This means you can easily program and debug in Kotlin, Java, C++, or C, depending on your needs. Who else is using Android Things? You may have seen the new voice-activated speakers from Polk, LG, and iHome, as well as smart displays from Lenovo, LG, and JBL. These devices showcase the powerful capabilities of the Google Assistant and are coming soon to stores near you. There are also lots of startups and design agencies using Android Things to prototype innovative ideas for all kinds of devices you're going to see very soon. We want to make it easy for anyone to start building IoT devices without having to own your own factory and without requiring lots of funding. This is all part of our efforts to democratize hardware development, making it accessible to more software developers out there. If you want to get started with Android Things, we have a great community website, androidthings.withgoogle.com, where you can see the developer kits and the interesting projects created by others. So what's next? Get some hardware, check out the documentation, download some sample source code, and try it out. And join our community to ask questions and share your ideas with others. Android Things 1.0 is now open for business and ready for production. I'm really looking forward to seeing all the exciting products that you build. I'm Wayne Pekarsky, and I'll see you next time.
Thanks for coming. Welcome to the Working with Work Manager session. My name is Samir Kataria. I'm a software engineer at Google.
Hi, my name is Rahul Ravikumar. I'm also a software engineer at Google.
And we both work on Android architecture components, particularly Work Manager. Let me grab my... All right, so what are we going to talk about today? We're going to give you a State of the Union about Work Manager. It was released at Google I/O. I want to give you an abbreviated guide to Work Manager. So for those of you who haven't used Work Manager before, we want to go over some of the basic APIs. And we're going to spend the most of the time talking about Work Manager, the questions you've asked, the things that have been frequently misunderstood, and also the new changes that we've made since I/O. So let's start with the State of the Union. There have been 11 releases of Work Manager since Google I/O, and these are alpha releases. Today was the 11th one. And beta is coming soon. So those of you who watched the keynote yesterday may have heard that beta is coming this month. This was news to us too, but it's coming this month. We were very close, but I guess we're doing it this month now. So we want to give you an abbreviated guide to Work Manager. And what is it, for those of you who are just completely new to this? It's a library for managing deferrable background work. It wraps Job Scheduler and Alarm Manager broadcast receivers. It's backwards compatible to API 14. And those of you who've used Job Scheduler will find many of the concepts very familiar. So let's talk about work. You've got a unit of background work, and we'll talk a little bit more about how we create it and how we enqueue it later. But you've got it, and how does Work Manager execute this work? This is a graph that might help you. While your process is up and running, we'll feed it to this executor that we have that does the work. It could be a thread pool. You can customize this thing. But your process may be killed, and Work Manager is guaranteed to do work. It may defer it, but it will do that work when the constraints for that work are met. So we also enqueue it in the background. So if you're API 23+, we use Job Scheduler. And before that, we use an Alarm Manager and broadcast receiver implementation. So whenever the signals are met, let's say that you've put in some work for a 2-hour time delay when you have network, when all of those conditions are met, it'll still go to the same executor.
All right. Let's do a quick API walkthrough for those who have not seen the API. So the fundamental unit of work in Work Manager is a worker. Here I'm defining a calculation worker. It extends the worker type. So now the only thing that you need to do when you define a new worker is to extend doWork. doWork returns a result. Here I'm returning a success. You can also return a retry or a fail. I'm doing some expensive calculation on a background thread, so you don't have to worry about threading here because Work Manager is guaranteed to schedule your work on a background thread. And here I'm returning a result.success synchronously. So that's it. I'm pretty much good to go. So now you've defined a worker. How do you actually make that work run? So for that, you need to enqueue a work request. So there are two types of work requests. One's a one-time, and the other one's a periodic work request. Here I'm using a one-time work request builder. And I'm building it with the calculation worker that I just defined in the previous slide. So I'm setting an initial delay, and this is a timing-based constraint. And this tells Work Manager to only run the work after 2 hours have passed since the point of enqueue. I'm also setting another constraint, which is the charging constraint. This tells Work Manager that this work is only eligible to run when the device is actually connected to our charging, when the device is actually charging. I add a tag. I'll talk about tags in more detail, and I'm finally calling .build. Now, all I need to do is to call getInstance and enqueue the work, and that's it. Now the work is scheduled. So now you've scheduled your work. You've defined a bunch of constraints. And it's hard to keep track of. And if you want to keep track of what state your work is in, then you want to call getWorkInfo by ID live data. And this returns a live data of a list of live data of a work info. And so work info is the type that determines the state of your work. And live data here is a lifecycle-aware observable. So once you attach it to a lifecycle owner and you define an observer, you can observe the state transitions of the work request. So it'll go something like, once you enqueue the work, it'll go into enqueued. Once the constraints are met, it'll go into a running. And then finally, because you return success, it'll go into the succeeded state. So Remember that tag that we added when we built the one-time work request? You can also get work infos by tag, live data. And tag is something that you associate with a work request. And there can be one to many. So you can associate the same tag to multiple work requests. And here, I'm calling get work infos by tag live data. It returns a live data again. Notice how it returns a list of work info and not a single work info. And again, I can do the same things that I did in the previous slide. So one of the coolest features of Work Manager is the ability to chain work. So that helps you define an acyclic graph of work. And here I'm asking Work Manager to begin with A, B, and C. And here, A, B, and C are work requests. And I'm saying that D and E are only eligible to run once all A, B, and C are done. And when I use the begin with API, I'm asking Work Manager to run A, B, and C potentially in parallel. Whether they actually run in parallel is determined by the capabilities of the device and the size of your thread pool. And finally, I'm calling a then on F, G, and H. Again, now F, G, and H will only run once all the preceding works are done. Finally, don't forget to call enqueue. That's when all the magic happens. So now you called enqueue. Now you might be wondering what begin with returns. So begin with actually returns an instance of work continuation. And a work continuation is a node in your acyclic graph. And this lends to a very fluent API. So every time you call begin with, it returns a new continuation. And every time you call .then, it returns a new instance of another continuation. Finally, don't forget to call enqueue. The one important thing that you need to remember is when you chain work, the outputs of parent or the outputs of the parent work requests become inputs to your descending work requests or your children. This helps you manage state and send state from the parent work to the descendant work. And so now, finally, Work Manager also exposes the APIs to cancel work. So for some reason, if you want to do that, you can cancel work by ID. And every work request has a unique ID. So here we are canceling work by that ID. And we can also cancel all work by tag. So those are the two APIs. And that's it.
And I want to point out that all the APIs we've been showing are for Alpha 11. So you may notice some slight changes for those of you who have been using this API before. But everything is live today. So let's talk a little bit about how you can get the most out of Work Manager. And these also include questions like, how do I do a certain type of task? Why does this work this way, a certain way? And the biggest one that we get a question about is threading. How does threading work in Work Manager? So we talked about a work request. Rahul just mentioned that. And you enqueue it. What happens to it then? So we have an internal, we call it an internal task executor. You can think of it as a single-threaded executor. And the enqueue goes to that, which stores it in a local database. So every app that uses Work Manager has a Work Manager database. This is the source of truth. This is where we keep track of the state of your work, your inputs and outputs, everything. With the dependency chains, everything goes in this database. So after it's been enqueued, sometime later, your constraints are met. And the OS tells you that. If you have no constraints, it's eligible to run it right away. If there are constraints, the OS will tell you, oh, you have network, you are charging right now, whatever it is. Same task executor uses a worker factory to create a worker. Worker factory is exactly what it is. It's a factory for workers. And you can make your own, you can customize, and do things with that. We'll talk more about that later. After the worker's been created, we execute it on an executor. And this is also a thing that you can actually customize. We'll talk more about that later as well. But what if you don't want to execute something on that executor? We give you a default one. You can specify your own, but what if you're using RxJava? What if you're using coroutines? What if you have your own bespoke solution that you want to use to run things in the background? This was a request that came up quite a lot when we first released Work Manager. So to do this, we want to provide you an API to let you do work on your own and just tell us when it's done. So you want to signal async work completion to us. And for that, we use a class called listenable future. Those of you who use Guava will be very familiar with this. But we've split it out, and the Guava team has helped us with this, so everybody's collaboratively worked on splitting this out to its own lightweight artifact, so you don't need a full Guava dependency for this. It's literally one or two classes now. And it's a future that can have one or more listeners, and those listeners can be invoked on a specified executor. That's all it is. It's very simple. So using this listenable future, we made a class called listenable worker, which only has one method that you need to override. It's called start work. We'll call start work on the main thread for you. You give us back a listenable future. You do whatever work you want on whatever thread you want, and when you're done, just set the result on the future, and we'll be able to listen for it, and we'll be able to react to it. So the actual threading model in Work Manager is, after your constraints are met, it goes to the task executor, which uses the worker factory to create a listenable worker. We call start work on it, and we also attach a listener so we can listen to whenever you're done. What this means is that the worker class, which is still around, is a simple listenable worker. So we've got the do work method that we talked about. We override the start work for you. We create a future. On that background executor that I talked about, the one we provide by default, we execute the work. And we, of course, return the future. So now we have two classes, worker and listenable worker. What's the differences between them? Workers, we consider those a simple class. For most use cases, we think that's sufficient, is a class that runs synchronously and on a pre-specified background thread. Listenable worker runs asynchronously on an unspecified background thread. So worker.doWork is a synchronous API. You're expected to finish what you're doing there. If you're trying to create a listenable worker, you may need to return a listenable future, which is an interface. If you have access to Guava, you have access to many kinds of listenable futures. If you don't have access to Guava or don't want to add the dependency, Resolvable Future is a lightweight implementation that we provide in Android X concurrent futures. So you can use that. So let's look at an example. One of the things that a lot of people are trying and doing incorrectly with workers is that they're trying to get locations. And we're going to specifically use the Fuse location provider client. So if you listen to the Kotlin Suspenders talk yesterday, they also use this. It's a GMS core API to asynchronously get your location. Remember that a worker class is synchronous. So if you attach a callback and later get informed about it, but return success, your work is already completed. It's not going to work the way you think it is. So first thing we do here, we're using a listenable worker, is we create a resolvable future. So this is the future that we'll return and do all our bookkeeping on. In the start work method, we'll check to see if we have permissions. If we don't, we'll set a failure on the future. Otherwise, what we'll do is we'll get that Fuse location provider's last location. This is kind of like a future in GMS core or Google Play Services world. And we'll call this get location method, which I'll go into, and then we return the future. So that's sort of the high-level start work. In the location, get location method, we'll use that task, and we'll add a listener to it. If the task is successful, we'll pass that location back with a success status. Otherwise, we'll set an exception on the future. So that's it. We've basically addressed like the three cases where we want to have a successful or an unsuccessful task, or if we don't have permissions. And Work Manager will attach that listener. It'll listen to the success or failure of your task and do the bookkeeping as necessary.
All right. Let's talk about operations. Now, remember, Sumir mentioned that Work Manager uses the database as a source of truth. So anytime you enqueue or you cancel work, we have to do some bookkeeping, and we have to make sure we keep track of what your intentions were. So these involve writes to a database, and because there are writes to a database, we have to do them on a background thread. So as a result, they're asynchronous. What if you actually wanted to do something after the enqueue happened or the cancel happened? So you want to make sure that those operations completed before you want to do some more stuff. So for that, we've introduced a new API. So now enqueue and cancel actually return a new type called operation. Operation is a very simple interface. It has two methods. So it has a getState API, which returns a live data of an operation.state. If you attach an observer to this live data, you will see that the operation transitions from an in progress to a successful or a failure. You can also call getResult, and this returns the familiar listenable feature type. And remember that this API will only return the terminal state of the operation. It won't give you the intermediate states. So If you're attaching a listener, you will only ever get a success or a failed, and with the exception if telling you why the failure happened.
Another question a lot of people have is, when is work stopped? What happens when you stop work on behalf of Work Manager? Oops. All right. So there's 3 cases when work is stopped. The first is very simple. Your constraints are no longer met. So you said, for example, that I need a network to do this upload task, but your network got lost. So we will stop your work at that point. A second case is that the OS preempted your work for some reason. For example, you exceeded the 10-minute time limit that the OS gives you to do your work. Or the device decided to go into doze mode for battery savings or something like that. And the third reason is that you just canceled your work somewhere else in your app. How do we stop work? There's a method, listenable worker on stopped. We call this method when we stop, so just override this and you get your stop signal right there. We also canceled that future that we talked about, so you can also just add your own listener and look for that. So this is when one of these 2 things happens for you, whichever one you're looking at, this is your signal to be a good citizen and clean up. Because after this is called, the process may be killed by the OS. So if the OS woke up your app's process just to run this work, it could actually kill it when it decides that the work should stop. And if you happen to return something after this signal, say you returned a success, we ignore it, because as far as we're concerned, your work has been stopped. Whatever you're doing is no longer necessary to be done. You can also poll for stoppages in your worker, so you can also call the isStopped method, and that'll tell you whether you've been signaled for stopping. So let's look at how you can be a good citizen and clean up. So let's say in this example, we're parsing a file asynchronously. Let's say it's a huge file, so you're doing it in a worker. And you've got that familiar resolvable future thing that I showed you earlier. You've also got this input stream, so you're reading a file. Right? So in start work, you say parse file. This is doing something asynchronously, and you return the future. Here's parse file. So you've got some executor or whatever, a coroutine, it doesn't matter. You're asynchronously doing that runnable that follows. So the first thing you might be doing is you're opening the file, you're reading each byte out of the file, doing something with that byte, and then when you're done, you set a success because you're done. And then you have the necessary try-catch finally after that, so that you can clean up after yourself. So how do we handle when your work gets stopped while this is executing? So like I said, we override the onStop method. Let's say that we want to just finish what we're doing. We could easily just close that input file stream. OK, so what happens now? You've done that. Let's go back to the code. Well, if you're in the middle of that read loop, and you close a file, it throws an exception, right? Next time you try to read something. Well, fortunately, you're already handling that exception right there, so it looks like you're good, right? You're done. Or are you? There's one more case that you forgot about here, which is that what if the onStop happens before you even open the file? So now you're no longer looking for that stop thing because you never got that signal. You'll read that file because it opened after you tried to close it, which it didn't do anything for. So you'll do all of this work. And how you fix it is use that isStop method. So basically, while you're in that loop, you can always just make sure that you're looking for stoppages. So this is a good example of how you would honor the OS's signal to you or Work Manager's signal to you that you should stop and be a good citizen.
Right. So every time you enqueue a method, every time you enqueue a work request, the work request goes through several state transitions, and I'll talk about how they look. So let's look at the life of a one-time work request. So when you enqueue a new work request, it can end up in one of 2 states. It can be blocked, if it's blocked on another work request, given it's a chained work, or it can be enqueued. Once the constraints are met, it goes into running. And this is the point at which the worker is being actively executed. Once, depending on the result that you return, on how you signal work completion, we'll take it to one of the terminal states. So if the worker returns success, then we'll terminate it with a succeeded state. If the worker returns a failure, then we'll mark it as a failure, and that also is a terminal state. At any point in time, while the worker was in a non-terminating state, if you call cancel, then if you actually retry, then we'll apply the back-off policy, and then we'll retry. So the worker will go back to the enqueued state. At any point in time, if you have a non-terminating state and you call cancel, it'll end up in canceled. So this is what a life of a one-time work request looks like. Now let's look at periodic work. Periodic work is almost the same. Because periodic work can't be chained, there is no blocked state. So it always ends up in the enqueued state. Once the constraints are met, it'll go into running. So whether you succeed or you retry, it'll go back into the enqueued state. Now, this might seem confusing. If you succeed, then the work really isn't done because it's a periodic work. We'll just wait for the next interval. If you fail and you ask us to retry, then we'll apply the appropriate back-off policy, and then we'll increment the run attempt count. So we'll tell you that this is the second time that you're trying to run it for that last period. And if you mark your work as failed, then we'll transition it to the failed state. At that point, your periodic work won't run again. And again, anytime your work is in a non-terminal state, and if you ask us to cancel it, we'll mark it canceled. So let's apply those rules to how life of a chain of work looks like. So here, A is the parent of all workers. So when you enqueue this chain of work, only A is in the enqueued state, and all descendants of A are actually blocked now, right? So let's assume A's constraints are met, and it goes into the running state. Once A is done, let's assume it succeeded. So it unblocks B and C now. So B and C now become unqueued, and then they go into running. And for the sake of the argument, let's assume that B succeeds and C fails. What happens now? Because B succeeded, it unblocks D. So D goes into the enqueued state. But notice what happened to E, F, and G. They all failed. So the key takeaway is that if a unit of work fails, then all descendant work is also marked as failed. If a unit of work is canceled, then all of its descendants are also marked canceled.
So I want to talk about something called unique work. And let's start with a little question here. What's wrong with this code? So you've got an application object in the onCreate. You're enqueuing some periodic work. The problem here, and I've seen this in a few bugs, is that this enqueues periodic work every time your app process starts. And that's probably not what you're trying to do. You're trying to set up a sink here. Let's say it's syncing your data every day. If you call this code every time the app starts, every time you've got another thing that's syncing your code, you really only want one of them. So unique work basically is something that lets you specify conflict policies for a database insert. Think of it like that. Like if you insert the same key into a database again, what do you want to happen? Do you want to overwrite what's already in there? You want to ignore what you're trying to do? That's what unique work does. It basically is a conflict policy for Work Manager. And here's the syntax for it. It's pretty simple. Unique name is that key. It's that something that uniquely identifies that chain of work. Policy is the existing work policy, or what we call the conflict policies. And then you obviously have your requests. So the existing work policies are the interesting things. There's 3 of them. The first one is keep, which is it keeps the existing unfinished work. So if you have things that are in blocked, running, or enqueued, it will keep them. And if the work is already finished or it's not there to begin with, it'll enqueue whatever you just sent along with that call. The next one is replace. It always replaces the work request in the database. If your work is running, it'll get stopped, as I described a few minutes earlier. It cancels the old work, and it stops it. That's what it does. Append is kind of a special one. It basically appends to that chain of work. So for example, this is useful if you're trying to do something in order. For example, you're trying to build a messaging app, and you're sending messages in order. So you may have a unique chain of work for sending messages, and you want to append new messages to the end of it. So it's basically creating a tree for you.
Right. Remember, Sumir mentioned that in one of his previous slides on how one can customize Work Manager. So let's look at all the things that you can do. So you can actually specify a worker factory that can be used to instantiate your workers and listenable workers. And this is especially useful in the context of dependency injection. So if you're using Dagger and you want to inject something into your worker before the worker starts, this is a good place to do that. You can also specify the default executor that you want all workers to use. You can specify the logging verbosity if you want, if you want to distinguish between a build and a release build, and you want to make sure you log more information to diagnose your problems. And then you can also specify various other job scheduler parameters, like number of jobs that you want us to send to job scheduler, the IDs of jobs that you want us to use, in case you're already using job scheduler before. So if you want to customize Work Manager, then you have to disable the default Work Manager initializer first. So for that, you have to add this entry to your manifest, and note the tools node remove. That means you're removing this. You don't want this entry to get merged. So now that you've disabled the default Work Manager initializer, the next step is to actually create a new instance of configuration. So here I'm using the configuration builder, and I'm overriding it to specify my own custom executor. So now that I've done that, I can just call workmanager.initialize. I specify the application context and the configuration, and I'm done. So make sure you do this in your application on create or a content provider on create, because the system, the operating system, can actually invoke job services on your behalf. And when job services are being invoked, Work Manager needs to be initialized.
Finally, the last thing we want to talk about before we wrap up is some tips for all the library developers out there. If you're using Work Manager in your library, you have some special use cases that we want to think about. So the general advice we give for library developers is, because Work Manager is a singleton and the application initializes it, as Rahul just showed you, you are not really in control of what's there. Rely on the defaults. So use the default worker factory. The default worker factory that we provide it creates workers and listable workers using reflection. Rely on that, because you don't know what else is happening. If you need some particular dependency injection or anything else of that sort, you'll have to have a contract with the app. Silo your work with tags. So Rahul also showed you how to tag your work. If you silo all your work, meaning you prefix or put your prefix or your package name or your library name in your tags, you can easily identify all the work that's yours. You don't have to worry about other people's work. You don't have to deal with any of that. You can just get your work and operate on just that if you don't know the IDs. Finally, we do provide the ability for apps to wipe away all work, and this is generally for privacy reasons. This is not something we expect to be called, but it's for that sort of critical use case where you have to wipe user data for some reason. So as a library developer, how do you find out if your work's been wiped or gone from under you? You should look at get last cancel all time millis. It's a very confusing name. OK, next steps. So get Work Manager if you haven't already. And for those of you who have, thank you very much. Your feedback's been invaluable. We're up to Alpha 11. So there's 3 general categories of artifacts here. There's the runtime. There's the KTX stuff, which includes a coroutines worker that we just put in. So you don't have to write your own. And then there's testing support as well. These are some helpful links. Schedule task with Work Manager is the developer.android.com section for Work Manager. There's the YouTube. On YouTube, there's the Google I/O 2018 talk, which talks about all the basics in much greater length. Some of those APIs have changed a little bit, but it's still broadly a good thing to read or to listen to. And also, please file your feedback at our public issue tracker. Beta is coming. We were told that this morning or last morning as well, so we're kind of, we have to go back to work. But thanks a lot. Please visit all the Jetpack libraries on the web, and we'll be outside for any questions that you might have. Thanks.
Thanks.
Everyone, the next session in this room will begin at 1:55 p.m. Thank you.
Hi, everyone. Thank you for joining us at Best Practices for Themes and Styles. I'm Alan.
Hi, my name is Nick Butcher.
And we're going to be talking about some ways to think about themes and styles at a high level and how to apply those when you're designing themes and styles for your application. So first, let's start at a high level, the way that designers create mocks and the way that developers are interpreting them. So here's the latest iteration of the Material Design theme palette. So if you're not using Material Design components for Android yet, you may recognize primary as the color primary attribute from the material theme in the platform, primary variant as something like color primary dark. And when you get a mock from your designer, you may be doing a mental mapping of, oh, well, this is going to be my primary dark color in my theme. This is going to be the primary color. And embedding those directly in your theme. But it's important to make sure that your designer understands that there are these canonical attributes. So if you're getting a mock that just has a hex color specified, it can be helpful to maybe push back a little bit and say, let's call this the primary variant, or let's call this the primary color. And it's great that we have all of these predefined theme colors with meaningful names and meaningful contrast ratios that have to exist between foreground and background and additional colors in the material palette. Occasionally, you will get a brand new color that doesn't exist anywhere, and finding a name for this may be difficult. So here we have a purple color that's a little bit lighter than our primary variant, and it has contrast against white, so we're going to be displaying white text on top of it. If we want to come up with a name for this, we should find something that can generalize, but is self-documenting and captures these constraints, so that if we decide, well, we had a purple theme, now we need a blue theme, we can reuse the name of that color and reuse those constraints. So you could move from purple to blue very smoothly. So what are we going to call that? Well, over in the material palette, we have these on colors. On primary means this is a foreground color displayed on a primary background, and we ensure that it's going to meet certain accessibility-related contrast ratios. So you'll be able to read the foreground text color against the background. We have on secondary, which does the same thing for secondary. So if we're displaying something on that light blue color, it would be black text. If we're displaying something on this purple color, it would be white text. So we can use these to generate the new name for this lighter primary color. What should we call that? Well, we're going to use on primary, so that determines the foreground color protection. For background color protection, we want to make sure that it contrasts a little bit with primary, so we'll include both of these in the name. We can call it something like primary light, which seems incredibly straightforward, and it is. So you can tell your designer, hey, every time we're talking about this lighter version of our primary color, let's refer to that as primary light, and it's going to have these constraints for foreground colors and background color protection. So if your designer decides, well, in this next screen, we want it to be blue instead of purple, we can continue to use the same constraints on this color and use our semantically defined color name in our theme as well. All right, similarly, we provide common patterns for text appearances. So here you see on the left, we have headline, overline, body. These are semantically defined terms. They're meaningful names for where these appearances are going to be used. And that determines the pixel size, that determines the font weight, that can determine the font itself, and that's going to determine the color. On the right, we see what these values actually map to. So in this case, headline is going to be Roboto, and in fact, we're using Roboto throughout our entire app. However, if we decided that instead we wanted to use, let's say, Comic Sans, we could make our headline map to Comic Sans. We wouldn't have to go through and create a new style everywhere in our application, because we do have these names that imply how they're used. So always make sure to use meaningful names when you're extracting patterns from your mocks and applying those in your implementation. So learn the material design attributes. They're documented at material.io. Make sure your designers learn them too, and use this as a common language when you're looking at mocks and when you get something new that may have a random gray color in it that you're going to see throughout your mocks. Make sure it has a name that you can use over and over again. And if you happen to be implementing dark mode, for anybody who attended that talk earlier today, you'll know that this gray needs to turn into a light white because it needs contrast against a certain text color or a certain other background color. Use meaningful attribute names. They should be more or less self-documenting, Something like primary light is going to have more constraints than just, it looks sort of like the primary color, and the text color should be consistent with other primary. So go ahead and document these somewhere. Start a doc that you share, or start an internal site that you share with your designers to make sure you're always using a common language when talking about the components, the colors, the reusable textiles in your designs. You'll expand beyond what's available in Material, I'm sure, but that's a good starting place to get a sense of how to name them and how to talk about them. And part of that is avoid hard coding values. So when you get a mock that just says, this is the hex color 4A36EF, make sure that you push back on that and say, no, this isn't a hex color. This color has some sort of meaning, and we need to be able to smoothly transition from this hex color to a hex color with similar constraints. All right, so now Nick is going to talk a little bit more about what this means in implementation.
Thank you. Right, so we talked a lot about then about supporting different semantically named values in your applications. And what that means on Android is essentially it can be implemented as theme attributes. And Alan said something really interesting there. He said, what happens if your design changes and all of a sudden instead of a purple theme, you have a blue theme? And how do you apply that? These semantic names protect you almost against these cases. And it's actually more widespread than you might realize. And I'm going to dig into that a little bit. So if you want to have areas of your app or screens which can support this kind of theming, there are different ways you could achieve this. One way might be that you just, say, define different styles. So in this one scenario, I'm going to set up a style to give it a certain appearance. We'll call that style 1. And in another scenario, I want it to look different, so I'll give it another style, style 2. The problem with this approach is that there's probably going to end up being a lot of duplication between style 1 and style 2. And there's now 2 places for you to maintain or bug fix or maybe refactor at some point. Using these semantical pointers to kind of describe what the appearance should be like, or in kind of coding terms, it's going to end up as a theme attribute, protects you against this. So while it might be more work to kind of like establish this language and to set up your styles to refer back to theme attributes, what it does is it actually ends up with just a single place, a single style, that will refer back to the theme attributes defined for a given theme. And the benefits of this is it's going to reduce that duplication. You don't end up with like 2 styles which are 80% the same, but have the potential to diverge in the future, which they will. It also localizes the modifications. So that means that if you need to change an attribute, you just go to that one place where it's defined and change that, rather than having to track it down where it's leaked out into all the variety of styles you have across your code base. It also has the benefit, I think, of consolidation. Like, how many times have you opened your colors XML file and found 50 different shades of very similar looking colors, and then you see a mock and it's not quite the same color, and you go, I don't know, I'll just create another color resource. Or is it just me that does that? It's kind of like protects you against this. You really, really, really want to kind of condense it down to this kind of small palette, which is used consistently throughout the application, so you have a nice look and feel. So to sum up, basically, this approach really, really helps you with the maintainability of your app. And so as such, I really urge you to prefer theme attributes where possible. By which I mean, if you find yourself writing code like this top line, so you're saying the text color should be, this color resource, almost think of that as a code smell. Like, just think for a second, hang on, is there this layout? Is there a chance this might appear in a different theme? Could this be like included in like a different area of the application? And if so, should I instead be looking at this bottom form using the question mark * syntax, which is how you refer to these theme attributes? So we talked about the importance of having these kind of semantical pointers, but like, how might your theme vary? So hopefully everyone's familiar that you can set a theme directly on an activity. So in this example, 2 activities are using Material Components, which is a dark theme, and then a light variant. Or perhaps you're using night mode, like Alan mentioned before, and is also talked about in the Cost of a Pixel talk earlier today. So this is a theme which will change between dark and light depending on the time of day. But what happens if you have a screen like this, which is from this is the Google I/O app, where we have largely similar content? So most of these list items are the same, but the design called for some of them to be light on dark and some to be dark on light. I mean, you can think of ways you might implement this as separate layouts, or perhaps setting text colors on bind or something like that. But both of those basically either leak out the sliding information beyond where you want it, or lead to like an explosion of more maintenance. Instead, what you probably want to do is look at applying themes at the view level rather than at the whole activity level. So the theme attribute was added, not theme attributes, the attribute Android theme was added in API 21, but also backported through Android X. So in this, you can set a theme on a view or a view group and apply a different theme to a subsection of your view hierarchy. So in these examples here, you might say you have a light theme and then apply a dark portion of it, or vice versa. You can do the same thing in code if need be by using the context theme wrapper, which takes an existing context which has a theme and overlays a style on top of it. I think it's really important to emphasize that fact that it is overlaid. That means that you have an existing theme, and any values from the theme you set on top of it are going to be applied on top. So you need to be a little bit conscious of this fact. Either you don't want to overlay a theme which supplies too many values. So for example, if I was using just materialComponents.light and I overlaid materialComponents.dark, they define a lot of the same attributes, and you might be relying on some of the attributes you set in the first theme to still be present, so you might overwrite too much. Conversely, you want to make sure the theme you are overwriting sets the things you need. So as such, you might want to take a look at these theme overlays, of which there are some in AppCompat or Material Components, or create your own theme overlays extending from them just to theme the attributes that you want, such that when it's overlaid on top of the existing theme, you get the resulting kind of combination of themes. One thing to note as well is that while the context theme wrapper approach looks tantalizingly close to dynamic theming, it's not. By which I mean that you have to apply a theme which you've defined at compile time. You can't use this technique to, say, take some server-derived color values or whatever and create a dynamic theme. This is all about this kind of ahead-of-time thinking.
All right, so before you start setting a bunch of theme attributes, it's important to understand how those are applied throughout the platform. So we're going to do a whirlwind tour of the layers of indirection that occur between what you see on screen and what's defined by the platform and what you're setting in your application themes. So at any point in your application, it's good to have a background understanding that you can point at something on screen and understand all of the layers of indirection, all of the theme attributes and styles that were applied to render it this way on screen. So if we want to set this color for a single button, how would we do that? Well, let's dive into the way that this gets resolved at runtime. So we have button defined in layout XML. That gets inflated in the button class. If you watch the Demystifying Themes and Styles talk that Chris Baines and I gave 2 years ago, you have a complete understanding of how this works. If you haven't watched that, go watch it. The important part is that the button style that you see here is pulled from the theme of the context in which the button is inflated. So relevant button style attribute here at the bottom of the screen. Next, where is that button style defined? It is defined on the material theme if we have not redefined it otherwise. So the default value there that you'll see in themesmaterial.xml is widget.material_button. Where do we find the definition for widget.material_button? Over in styles material. So we can see here the background is defined to be this button default material drawable. We'll also notice that right below that bordered ink button style, we have a colored bordered ink button style. Which, if we've looked over the material spec, we realize is probably going to be a little bit closer because it provides a color in the button. So let's dive into the background that's used there to see what gets pulled from our theme and what we might be able to change. In the button-colored-material.xml, you'll notice the XML file names match up exactly with the drawable names. So there's an easy chain that you can follow. We have a shape. It's a rectangle. It is colored with a tint, which is our button-colored background material. This gets applied to the white color of the shape, so it's got a solid white fill here. So let's dig into that tint and see what's going to be applied on top of that white color. It is our color accent. So this is a color state list. It is named button-colored-background-material.xml, which is the exact name of the color that we were just looking at. Again, a very clear line of indirection. So where does this color accent come from? Well, because it's a theme attribute, it's going to come from whatever exists in our application theme. As I mentioned, that inherits from material, and if we haven't redefined color accent to be anything else, it will be the default teal. So here are all the levels of indirection that we've just looked at. Some of the important ones are if we want to change the style for all buttons that get inflated, that's our button style in the theme that we could set. The button style that we're getting by default is widget.material_button. we can change that to something else like button.colored in our theme if we wanted colored buttons everywhere. We can also change our colored accent, which is what gets loaded by the colored button style. So if we set that in our theme, that gets used everywhere. We'll see that color everywhere. But what we want to do is one button. So what would happen if we set button style on our activity theme? We would see colored buttons everywhere. We don't want to do that. What would happen if we set it in the style attribute on our button in XML? We would see it only on that single button, which is what we want. But now we're getting the default teal color from our theme. So how can we fix that? Well, what if we set color accent on our activity theme? Now we're getting that blue button, but we're also getting blue switches and blue everything else that inherits color accent. And if you just do a search over the platform XML files for color accent, you'll see it in a lot of places. So instead, we can set it we could try setting it in layout XML. You'll notice that this does absolutely nothing because it's a theme attribute, and you shouldn't try to set theme attributes directly in layout XML. Theme attributes get set in your theme. So what we'll actually do is create a theme overlay, as Nick was just talking about, that sets just that color and contains nothing else. We will apply that to the button using Android theme in layout XML, and we'll get what we wanted. So back to Nick for more implementation.
Cheers. So I said you should prefer theme attributes where you can. But to do so, you kind of need to know what is out there, what exists. And honestly, I don't have a great answer for this for you, other than looking through the attrs file of, this is from the Android platform, or from AppCompat, or material components. So looking through these, they're not that long. You can see what is available for you that you can reference rather than hard coding. Conversely, you can look at some of the common themes, like themes.material, and see which theme attributes they set. And as such, you are able to reference or override yourself. So it's good to kind of have a look through these and get an idea of what's out there. One note is that you might see that some theme attributes are kind of double defined. So the platform defines a Android color control highlight, and then AppCompat defines its own in order to provide backward compatible functionality. So which do you use? Basically, the answer is always, if there is one defined in the libraries like AppCompat or Material Components, prefer that, because they'll tend to set the platform one for you and then be available for backwards compatibility and so on. You can, of course, refer to these theme attributes in code using something like this, where we're doing obtain style attributes to get hold of it, and then using KTX's get color or throw to make it a little bit more convenient. So far, we've talked about using platform theme attributes, and you absolutely should. But you can also create your own, and you should do that as well to make your applications more themable. Let's walk through an example of what this looks like. So here from the Dev Summit application, we have two screens which display very similar layouts, a list of sessions in both the schedule and on a speaker details. They only differ in basically how far, some space of the left, the key line, essentially, that we wanted to align it to. One needs to leave room for the sticky header time things. So to accomplish this, we defined our own theme attribute. So here this is in our attrs file called session list keyline. And then in the different activity themes for those two screens, we can provide different dimension values for that keyline. And then we just have to have a single layout which references that, that theme attribute using the question mark attrs syntax in order to vary it without having to create separate layouts which you then have to maintain, etc. Another place that theming comes in absolute massive handiness is theming drawables. So we looked at an example from the platform button about how from API 21 onwards, all platform drawables support tints and tint modes. So here we're applying the color button normal. You can also do this in vectors, where they support theme attributes both for tints as well as for fills and strokes. So you can use this not just from 21 onwards, but in the backwards compatibility library as well. And if you need to apply tints in a backwards compatible way to exist prior to 21, you can use drawable compat like this in order to set some tints on an existing drawable. Drawable compat also offers an override which lets you set a tint list, a color state list to be applied, which is something we have learned is to be extremely handy. So like the example we looked at before, you can define a single color state list which provides these different tints or colors for different states. So this example is taken from text primary. And one of the things I love about color state lists is some of the improvements that arrived in Marshmallow 23, which allowed you to separate out the color and an alpha component. Why this is great is because this really protects you against that explosion of like 20 different opacities of black you might have in your colors file. by actually separating out the kind of the color information from the alpha information allows you to define more specifically what you want. So here we're saying, say this is a light screen, so color foreground will be dark. You can say the text should be black, and it should have these different alphas, depending if it's enabled or disabled in these two examples here. So you don't have to define all these different combinations. You define specifically the semantically named things, like disabled alpha, primary content alpha, and foreground color separately, and then they get combined by the color state list at runtime. One thing to note is I've actually cheated here and changed the Android alpha to app alpha because AppCompat backports this new function, new features added to color state list, but it requires you to use app alpha. One thing to note is that the alpha channel of the color and the alpha are combined, they're multiplied. So be careful, don't do this essentially. If you specify this is like, say, a 50% white text if you don't speak hex, and a 50% alpha, you'll end up with a 25% alpha white. So you probably want to refer to colors which have full alpha, and then only supply variable alphas via the alpha channel separately. And like I said, AppCompat backports this, so use AppCompat resources to inflate that in order to get this backwards compatible behavior, and then you can apply those to drawables. So overall, if you apply this theming, you can get to a state like this. So on the left, these look quite similar, but on the left we have the Google I/O app, which we forked to create the Android Dev Summit application. And to retheme it to fit in with the look and feel of this conference rather than I/O, this is basically the diff. Essentially, we just had to change a few of these semantically named colors. And if we go back, this ripples outwards to all the components. So the fab changes, the bottom nav changes, some of the tints on drawables changes, the star color changes. Like, think about if your product manager comes to you and says, hey, the company's had a rebrand, and we're changing all the colors. Wouldn't you rather just have a diff that looked like this, rather than trying to go through every layout XML or colors file and work out which color is which and where it's used, and then can I change this, and where is it going to affect? You really want to limit the changes to these semantic names. So as a kind of summary of this, really theme attribute all the things, essentially. Use them as this kind of protection. You should probably push that kind of semantic system back upwards to your designers so that they're kind of giving you values that work with this. In your layout XMLs, prefer that theme attribute syntax, the question mark atra syntax, or be careful when you're not writing that, thinking, is this a smell? Should I be doing something else? And with your drawables, think about using tints, so to protect yourself against these changes down the line. Just think if all these those drawables had been pings instead, and I had to, we had a rebrand, am I going to have to completely generate all these pings again with a new color which is already baked into it? Ignore that, don't do that, use tints instead. Basically, if every time you use a PNG, think, should this be a PNG? Is this going to be usable or tintable later? Maybe prefer a vector. Do prefer vectors. Pretty much the only time you should be using PNGs is for 9 patches. So that's a summary. Protect yourself using semantic names and theme attributes, and have fun with themes and styles. Cheers.
Hi, everyone. I'm Louie, and I'm engineer on the Android Toolkit team. Today, I'm going to be sharing some best practices when using the AndroidX preference library, part of Jetpack. I'm going to be covering some background behind preferences and try to clear up any confusion between preferences and shared preferences. I'll demonstrate how to build a settings screen and some useful features you can use along the way. And I'm going to cover how you can use multiple settings screens, which is especially useful if you're migrating your existing architecture to the AndroidX library. But first, some background. What are preferences? The preference library is a framework for building interactive setting screens. It handles building and updating the UI, so all you need to do is define a list of settings to be displayed to the user. And it also handles interacting with device storage, so that any value that the user changes will ultimately get persisted to the device without you having to worry about it. Preferences itself currently exists in 2 separate forms. First, the framework preference API. This has been bundled with the Android framework since the first version of Android, so 11 years ago now. Since it is part of the framework, any new features and bug fixes we add only make their way to the newer versions of Android. And given that the design has changed a lot over the last 11 years as well, the framework API is themed differently depending on which version of Android the device is running on. As a result of these, we're no longer maintaining the framework API, and instead we recommend using the Android X library. The Android X preference library, previously known as the V7 and V14 preference support libraries, is unbundled from the framework. This means it can be regularly updated with any new features and bug fixes we push. The library itself is backwards compatible down to API 14 and uses the same updated material theme across all your devices. This results in a consistent experience for your users. And how does this all relate to shared preferences, you may be wondering? The shared preference APIs allow you to persist key value pairs of data to the device. They're used internally by the preference library to save and retrieve any values that a user configures, but aren't actually part of the library itself, just a lower layer. So let's start building our settings screen. We're going to start off by building the simple hierarchy on the right. We have a preference with a switch that allows the user to toggle state, and a preference that just displays text. I'm going to cover how you should structure your architecture, and also some basic attributes you should be aware of when you're using the preference library. So we're going to start at the top with a simple activity that just acts as a container for our hierarchy. This should be an app-compat activity with an app-compat-based theme. The activity itself is basically just a container for this preference fragment compat, which is the main entry point when using the preference library. All our interesting preferences and configuration will happen in here. And this fragment itself just wraps a hierarchy of individual preferences, which can either be defined in an XML resource or defined programmatically at runtime. In this talk, we're going to focus on XML. So the activity itself is, again, just a simple container for our fragment. So we just have some simple fragment boilerplate, and all we need to do here is just show our settings fragment. The fragment, again, fairly simple. All you need to do is override this one method on create preferences, and then just set up the hierarchy that you're going to inflate and show to the user. All the interesting definition actually happens in the XML. So this is our XML file. We start with a root preference screen object, and this basically is the main container for the entire hierarchy. Everything should go inside of this, and this should be the root element. Note that you should also place your preference XML resource files in the res XML directory. So now we can add our first preference. This is a basic preference. It doesn't have anything, any widget associated with it. And we have these three important attributes here. The title and summary are the visual title and the visual summary actually displayed to the user on the screen, as you can see on the right. And the key is pretty important for two reasons. Firstly, if this preference were to persist any state to the device, then this is the key that the shared preference instance would use. And also, this key allows you to interact with this preference later on in your lifecycle. So it's very important to declare a key for every preference in your hierarchy. And now we can add a switch preference compat. This is a type of preference, very similar to before, but now we have a switch widget. So whenever the user toggles the state of this preference, this will update the Boolean value persisted to the key defined here. Now that we've built this simple hierarchy, I'll show you some other useful features we can add to make this even better. Here's the hierarchy we're going to end up with. There's quite a lot more going on here, so we're going to take it step by step. First, I'm going to cover categories, which allow you to visually split up a complex screen into groups of similar preferences. Then preferences that open dialogues, which allow for more complex configuration than just a simple Boolean switch. I'm going to talk a bit about dynamic summaries and also cover dependencies. So continuing from where we left off before, these are the same preferences had before, just without the root preference screen tag for verbosity. One of these controls syncing, and one just displays static information about the application. Although this is kind of simple now, there's only two things in the hierarchy, the more we add to this hierarchy, the harder it's going to be for a user to actually see what preference does what. We can use preference categories to help separate this up into logical subsections. To do this, we simply wrap these preference objects with a preference category tag. And as you can see, this now adds an accented title above these groups. Again, it's important to set a key for these, so it'll be correctly persisted state. And the title, again, same as before, same attribute, just displayed slightly differently. Next, we're going to add an edit text preference. Similar to a switch preference compat in that it's a subset of a preference, this preference uses a dialog to allow persisting a string value. So when the user taps on this preference, we automatically open a dialog for you, which contains an editable text field. And when the user taps on OK, this value is then persisted. However, this gives us some interesting question. What do we set for the summary here? Right now, there's no summary, so it's quite hard for the user to see what the current state is. And we would like to show the user what they've actually saved, so they know what they've done. But since this can change dynamically at runtime, we can't just put a string here. The answer here is to use a simple summary provider. This is added recently in the 1.1 alpha release, and it's part of a broad category of things we call dynamic summaries. I'll cover more about that later on. But this simple attribute, when set to true, will mean that the preference summary will automatically display either the value saved for the preference or the text not set if there isn't any value set. So now we have a way for the user to set a sync code, and they can see that the value they've set automatically. However, there's one problem here. It doesn't really make much sense for the user to be able to change this field if syncing actually isn't enabled. We can use a dependency here to fix that. Essentially, setting a dependency allows another preference to control the state of this preference. So we set the key of the switch preference compat that will control this preference. So this means that whenever the switch preference is turned off, as it is here, the actual preference is grayed out and can no longer be interacted with. And when the switch is turned on, the preference returns to normal and can be interacted with. Our hierarchy is almost complete from the example that we gave. The only thing we'd now like to do is set a useful summary for this switch. Right now, enable periodic syncing is on, but what does that actually mean? Have we synced recently? Maybe there's a problem connecting to the server. So we can use a custom dynamic summary here to display to the user when we've last synced, providing some more useful context. In general, dynamic summaries are useful in two sort of broad scenarios. Firstly, if you'd like to provide the user with more context behind a specific preference and what it means. So in this case, we'd like to tell them when we've last synced the device. Or it can also be useful if you'd like to display some dynamic information. This could be something like a version information of your application, or even user information such as a specific ID or email address. To set a dynamic summary, we use the summary provider interface. We can use this to either react to the internal state of the preference, or just use it as a callback to generate our own dynamic summary for external state. Here we set the type as switch preference compat, as that is the type of preference that we're setting the summary for. When the preference is checked, in other words, when syncing is enabled, we want to just display the last time we successfully synced. And otherwise, we're just going to say it's disabled, so it's clear to the user. And this is all there really is to it. All we need to do now is just set this on the preference. So to do that, we call find preference using the key we previously assigned in the XML. And then we just set the summary provider. This and any other similar configuration should be done in onCreate preferences in your preference fragment compat. And now, whenever a user toggles the state of the preference, the summary will automatically be updated based on the constraints we defined. Now that we've built our more advanced hierarchy, I'm going to cover using separate hierarchies and separate screens. Oftentimes, you'll want to split up more complex hierarchies into separate screens, making sure that less important preferences aren't cluttering up your main screen and making it hard for the user to focus on the things they actually want to change. If you're already using the Framework API and looking to migrate, there are some different ways you may have structured your separate screens. And if you're starting afresh with the AndroidX preference library, you may be wondering what the best way of handling this is. But first, let's just recap how a single screen looks. We have our activity at the top, which will internally wrap a fragment, which then contains its actual hierarchy. We can kind of consider the fragment and the hierarchy to be a sort of a screen of settings. So in reality, we just have an activity which loads a settings screen, which is this. And this works fine when we have one screen. But what if our hierarchy looks something like this? Now, on our first screen, we have links to other screens. So the sync will link to a screen of sync-related preferences, and messages will link to some more specific messages-related preferences. How does this look like with our architecture? It's actually very simple to what we've done previously with a single screen. The initial settings screen will just be, just as before, a preference fragment compat with a hierarchy. And then the sync settings screen will also be a preference fragment compat with its own hierarchy, and so on for any other screens you may have. All we need to do now differently is just define a link between the sync preference object and the sync settings fragment. So whenever the user clicks on this preference, we will load the related screen. So we'll start off in this state, pointing to the initial settings screen. When the user taps a preference, now that we've already defined this link, we're just going to swap out the screen from underneath. And because we're still using preferences to act as the link, the initial settings hierarchy is going to be just as we've done before. So again, we start with the root preference screen tag, and we just have two basic preferences, one for syncing and one for messages. It's important well, you may want to add an icon here to the start of the preference to provide some more context to the user, as we don't really have an important summary display here. This is just done by defining a drawable with the icon attribute. So this will just be something in your res drawable directory. And now the only thing left to do is just define the links between the fragments. So to do this, we use the fragment attribute, and we just set the fully qualified class name of the fragment. If your fragment is a nested inner class, you'll need to use the $sign to separate the outer class and the inner class. And that's it for the hierarchy. The activity is very similar to what we had before. We just set the initial setting screen to be displayed. The only difference here is that we should implement this method, onPreferenceStartFragment. This method is called when a user taps on a preference that has an associated fragment and allows you to customize any transitions or animations between fragments. There is a default implementation, so if you don't override this method, we will still handle it for you, but you won't have any nice transitions or animations that you may want. And the fragments are going to be exactly the same as before. Again, all we need to do here is just override onCreatePreferences and set the relevant XML resource. And that's really it now. Whenever a user taps on the messages or the sync preference, the corresponding fragment will be automatically displayed to the user. So to wrap some things up, we've recently released 1.1 Alpha 1, so please, if you haven't already, get it. Try using dynamic summaries and other recent features. Please file any bugs and feature requests to this component on issuetracker.google.com. We've recently updated the Android settings guide to make use of the AndroidX preference library. Please check it out for further information on some of the things I've talked about in this talk and some other features out of the scope of this talk. And we're working on template for Android Studio as well as public samples demonstrating this new library coming soon. For more information on Android Jetpack, you can go to developer.android.com/jetpack. And thank you for listening.
Everyone, our next session will begin in just over 10 minutes. Thank you.
Hey, my name is Cameron Ketchum. I work on the Material Design Components team, or MDC Android for short, and I work out of the New York City office.
And my name is Gautam Sujit. I also work on MDC Android, and I'm based in San Francisco.
And we're going to talk a little bit about material design components and how you can theme your app. So quickly, what we're going to discuss, a brief history of material design, what material theming is, using material design components, the color type and shape subsystems, how to apply these subsystems, as well as our release process, and a little bit about contributing. So quickly, just a brief history of Material Design Library. Material Design was first announced in 2014, and there wasn't a design library. Then at I/O in 2015, a year later, Google finally announced the Design Support Library, which helped bring a lot of code for material design for certain components, including navigation drawer, loading action button, snack bar, etc. But there still wasn't that much. And at I/O this year, we announced material theming with the explicit goal to have a larger engineering team behind it. So we're working on implementing a lot of the components based on the material design spec. So material theming. What was the original problem with material design? Well, it was a great initial version of a design system. It worked well in a lot of cases, but it fell short with the expression of brand. So here's an example of an email app. And it looks kind of like every other app that uses material design, and it's kind of hard to tell that it's even an email app, in my opinion. Here's an example of the kinds of things that you can do with material theming to make your app stand out. And we're going to get into those details in a bit. So quickly, how does theming work? Basically, material theming is a system that we've designed to help you create a unique design for your app. You just need to decide on a few things, such as fonts, colors, shapes, etc. And this is a material design sketch plugin that can be used, which should help you create design ideas that you can use to build your app. Take a look at material.io for more info about that tool. Here's a few material studies that we've done, which just show examples of material theming, and you can see that they all look quite different. And there's also a lot more of these on material.io.
Cool. So now let's get talking about how to actually get started using the Material Components Library. So imagine this scenario that we'll come back to a couple times throughout this talk. You've got this fairly plain app that you built from just straight app compat, and your teammate asks you to redesign this using the material design spec. So how do you go about doing this? So you may be familiar with the support library design package, this V28 version that you can use to get our library. And you can use this, however, this is no longer being updated, so you should try and use the com.google.android material library as well as AndroidX. One thing to note, you can't use the com.android support and com.google Android packages together. So if you want to switch over to AndroidX, there's a nice refactor tool on the developer.android site that'll help you refactor your app. And then the next thing you'll need to do is use our material themes. So we provide this set of themes that corresponds to the existing app compat themes. And these themes provide you with a range of attributes that help you do some of the shape, color, type theming that we're going to be talking about, as well as a set of default styles that you can use across all of our components. So for example, if your theme extends from AppCompat Lite, all you need to do is switch over to theme.materialcomponents.lite, and you should have all of our attributes as well as all of our component styles. So as I mentioned, there's a lot of new attributes that we're going to be introducing. And if you try to use our components without these attributes defined, you're going to get a theme enforcement error at runtime. Pretty much the styles look for these attributes in your theme, and if they don't exist, it's going to crash at runtime. So the solution to this is, of course, use our theme. It'll give you all the attributes. If you're not quite ready to switch over to our full theme quite yet, you just want to get the attributes and none of the styles, you can use what are called the bridge themes. And what these bridge themes do is they provide you all the attributes you need to do styling, but they don't give you any of the default styles. So you can opt into using our component styles one by one as you're ready to switch over. So for example, if you're extending from a bridge theme and you want to opt in to use our bottom app bar style, you would define the default bottom app bar style in your theme, and then all of your bottom app bars would get the material component style.
So now we're just going to talk a little bit about some new components. With material theming, we introduced a few new things, such as the bottom app bar. The bottom app bar displays navigation and key actions at the bottom of mobile screens, which is great for people who are just one-handed using their thumb to interact with the device. It's pretty simple. It uses a coordinator layout to coordinate the motion between a bottom app bar and a floating action button. So here we just have simple XML for the bottom app bar. A few of the things that you can do is set the vertical offset of the fab. You can also set the fab cradle margin, which is the distance between the fab and the bottom app bar, as well as the rounded corner radius, which is where the corner where the bottom app bar meets the fab. You can have the bottom app bar hide on scroll. And you can also set this alignment mode. It will automatically animate the fab for you, and it's useful if you're navigating between different fragments or views and want to give a visual distinction between different screens. If you're already using a toolbar, it's super easy to start using the bottom app bar. If you're setting the support action bar for the toolbar, just set it for the bottom app bar instead, and everything else works the same way. But you can also use an on-menu item click listener directly on the bottom app bar.
We also have what's a revamped version of the button that we're calling Material Button. It's been revamped to make styling much simpler. So if you just put this Material Button component in your XML, you'll get a styled button. However, if you're using our full theme, you can actually just use a button tag in your XML, and we do what's called custom view inflation, where this tag will automatically inflate into a Material Button tag. And then, of course, you can set the disabled state on this button, and all the states will transfer over, colors will transfer over. You can set an icon on this button just by setting the icon attribute as well as this icon style. And this style is optional, but what it'll do is it'll adjust the padding slightly to achieve a more even visual balance on the button when the icon is present. You can change the icon size just using that attribute. You can set the outline button style, which is one of the default styles that we provide for this button to get this hairline outline button. You can set the background tint of the button by setting the background tint attribute, and you can provide a color state list here. So in this case, it's purple when the button is enabled and gray when it's disabled. You can set some other attributes, such as stroke width, stroke color, corner radius on this button to get some styling. You can also create just an icon-only button. In this case, we're setting the icon as well as setting the icon padding to 0 so that the icon is centered in the button. And we are also setting the content description on this button. So since there's no text, for accessibility reasons, you should set a content description so that people will know what the button's about. You can also set the ripple color on the button. So for example, if you just set purple ripple on here, it'll be applied to the button. You can set either a color state list or just a hex value here. And as you can see, it's like a purple ripple on the button, but that's because there's some alpha already inherent in the ripple. So it's a purple ripple on top of a green button. And these are some of the examples of the other components that we provide in this library. We have several different styles of chips. We have text fields with filled and outline styles, password show and hide functionality, and a character counter. And then we have some highly customizable tab layouts as well.
OK, now a little bit about theming. MDC relies heavily on the built-in theming of Android. So here's just a quick refresher of how themes and styles work. Anything applied directly to a view in XML is used first. So changing an attribute here will only change this single view. You can also update the style. So if you set an attribute in a style, changing this here will affect any views that are using this style. If it's not defined in a style or there's no style set, it'll go back to the default style. So here, if you want to change the way a whole group of components look, you can set the default style. And then finally, if the attribute isn't defined anywhere else, it'll look in the theme. And the way material theming works normally is there's a set of top-level attributes that you should override in your theme for typography, colors, shapes, etc., and also the default styles for all of the components. But if you need more fine-grained control, you can hook in any of these layers and change like just the color of a single view or just the color of like all of a certain component. So here's an example from our library of the chip style. It defines a few values which reference theme attributes. And the power of this design comes from the fact that other styles in our library can reference these same attributes. So here's an example of a button. And both of these have the same shape appearance, which is this small component shape appearance. That means that if we want to update the look and feel of our app for these small components, all we have to do is update this attribute in one place in our theme. And we'll show you an example of how to do that in a little bit. What are the effects of each of these theme attributes? Unfortunately, it's not totally straightforward. We try to apply theme attributes in a way that will make sense. But it's definitely possible for you to pick values for like different colors that may not look great together. You should probably check out material.io for each component to see how it'll react. But another simple solution that you could do potentially is to make like a debug theme, which just sets wacky values to different attributes and then see how things look. But for instance, here's the bottom map bar page on the material.io site. And you can see there that the container itself is like a surface, and the icons are the on surface. We'll talk about which attributes you can modify, as well as things to look out for in the next section. So theming subsystems. We currently have 3 theming subsystems, type, color, and shape. And these are the knobs that you as a developer should tweak in order to theme your app. Hopefully, most of you are familiar with text appearances, but we've incorporated material theming, which uses theme attributes to reference these text appearances. So here's an example of a toolbar which uses the headline 6 attribute rather than style directly. And here's some copy that uses the body 1 attribute. These are the type attributes that we've defined. So if you override any of these in your theme, you can set the style and look of your app. Color is another one. And you're probably familiar with the AppCompat color primary and color accent. For material theming, we have a wider range of colors so that you have more control over the color of different parts of your app. These are the semantic names of the expanded palette of colors that work with color theming. On the top here, we have primary variant, secondary variant. Those are all the brand colors. Those are the things that you should generally theme to be the style of your app. There's also a background, surface, and error colors. You can style those, but you don't necessarily have to. And then the on primary, on secondary, those on variant of colors, those need to be accessible when they're drawn on top of the other colors. So for instance, on primary, that will be drawn on top of the primary color. So if you have text that's shown on top of the primary background, it should be the on primary color. These are the color attributes that we've defined. You can see that there's a lot of new ones. We tried to reuse some that came from AppCompat, and we also have the Android color background that we use, which is just the regular Android version of that attribute. Shape is another subsystem that you can theme, and it all happens with material shape drawable. So we're adding material shape drawable as the background for shape themable components, such as buttons, cards, fab, bottom app bar, bottom sheet, chips, etc. And the way it works is with edge and corner treatments. So we have edge and corner treatments defined for rounded and cut corner, which is pretty much every button or interactable component that you're going to find. But you can always create your own as well. So here's an example of Kotlin code which defines a rounded corner treatment and sets that to the material shape drawable to apply just rounded corners to everything. And here is the XML version as well. So if you want to do it in XML, we have a new attribute called shape appearance. And it's similar to text appearance. The attributes here are the corner family and the corner size, and this sets it to be a rounded corner with 24 dp radius. And you can override individual corners. So here, we're just overriding the top left corner to be cut and the bottom right corner to have a corner size of 0. And you can do the same thing in XML. One thing to notice is that we're using a shape appearance overlay here, which is basically the same thing, except for we only define the attributes that we want to override. So it's similar to a theme overlay in that the material button on its own already has a shape appearance by default. And here we're just setting the top left corner to be cut and the bottom right corner to be 0 dp. Everything else will be inherited from the style of the material button. One key idea of material theming is to add consistency to your app. So we've defined these shape mappings to help. These are different groups of components that can help give your app a more consistent looking feel by connecting surfaces through shape. So there's small, medium, and large components. And these are the attributes that you can set in your theme. So if you want to restyle all the small components to have a cut right corner or something, you can do that. Here's an example where, just like I said, we're overriding the small component style. So we redefine the small appearance, the small component shape appearance in the theme to our style. And here we're setting the top right corner to be cut. And we're also setting the parent here, so that will inherit all of the rounded corners for the other parts. Shadow is something that we want to mention as well. Native elevation is supported for convex shapes on Lollipop for API 21 and up, but we're backporting shadows to API 15 for both concave and convex shapes for common cases, such as rounded or cut corners, as well as for the bottom map bar. Because this has the cut out inside of it, it won't get native shadow, so we fake the shadow with a gradient.
So now that we've heard a bit about our theming subsystems, let's look at how to actually apply those to your app. So coming back to the scenario again, say you have this AppCompat app that you want to apply some of these theming subsystems to. So we're going to be building something that looks a little like this. And obviously, when you build your own apps, it'll look much more beautiful and cohesive than this, but we're tweaking as many knobs as we can to show you some of the functionality of what we built. So first thing you'd have to do is, if you're using an AppCompat light no action bar theme, you can switch over to the Material Components theme. And in this case, you'll notice we're using the bridge theme because we want to opt into using those components one by one. But generally, we recommend that you switch to the full theme, the regular theme, and see how it looks first before trying out the bridge theme. So let's say first thing you do is you set these theme color attributes. So some of the existing ones that you already know are color primary and color secondary. Those still exist. And then some of the new theme color attributes, such as color on primary, on secondary, color surface, and color on surface are also set. You'll see this color secondary doesn't really show up anywhere in your app yet, but it will. Next thing we want to do is get material buttons. So before we had those AppCompat buttons, and then if you set the material button style in your theme, all of your buttons should turn into material buttons when you change the XML tag. As I mentioned before, if you're using our full theme, this inflation happens automatically, so you don't actually have to change this XML at all. We have a bunch of other default styles that we've laid out here. All of our components have a default style that you can set in the theme. It's generally just component name plus style. For example, if you want to set the card style, you would set material card view style in your theme. And then we're going to be applying, you should also change the card view to material card view, in this case in your XML. And then we're going to be applying some attributes to these cards. So for instance, you can set card elevation, stroke color, and stroke width. And that'll show up across all of your cards because it's setting the default style, and all the cards look at this default style. And then say you wanted to change the base style of all the buttons. You would define your own button style and set the parent of it to outline button, which is one of our default styles. And then all of your buttons change into outline buttons. We can now apply some shape theming to all of your buttons. So we're going to define the shape appearance shaped button style. And in that button style, we're going to set the right corners to be cut and the left corners to be rounded. And we're going to set the corner size. And now you have this arrow-shaped button. You can also do this using a shape appearance overlay. Since buttons have a rounded corner by default, you don't really have to set the rounded corner for the left side. So if you use the shape appearance overlay, you can just set what you're changing, and it'll take effect as normal. And then say we wanted to have some icon buttons. You would define this icon button style, set the paddings and min widths as you want, and then apply this to your button directly in the XML, as well as setting that icon and content description. And then you have the share icon button instead of that share text button. You can also switch over to the bottom app bar. So for this, you'd have to set the bottom app bar style in your theme, and then remove the top app bar from your XML layout and add this bottom app bar here. You can also add a floating action button cradled into this bottom app bar by adding the floating action button to your layout and then setting the layout anchor attribute to point to the ID of the bottom app bar. You'll notice that this fab has that teal color from AppCompat, and that's because we haven't set the default floating action button style yet. So once you set that, you'll see that it's now using color secondary and color on secondary, and it has that ripple effect as well. Then we can do some text styling for the content of our cards. Say you want all of your text to be color on surface rather than whatever it was previously. We're going to be using what's called a material theme overlay, which I'll talk about in just a second. But this material theme overlay pretty much sets the theme for all the contents of that component. So in this case, we're setting the text color primary and tertiary to set the text color of our notes here. And so material theme overlay, you might have heard of Android theme. It's the way you can style a subsection of your view hierarchy. And one common usage of this is to style, say, a dark colored toolbar in your app. The shortcoming of Android theme is that it doesn't work in default styles. So for instance, if you wanted to style all of your cards, you can't really set Android theme. So material theme overlay is an attribute that we've defined that's supported by our components, and it does work in default styles. So you can set this in your default styles for your components and have it theme the subviews of your components. Lastly, we'll do some text appearance theming. So previously, the title had this hard-coded text appearance style. Now we're going to be switching over to our new text appearance attributes, and similarly for the note body as well. And then we can apply some styling to this. So for example, if you change headline 6 to be Comic Sans, for instance, you can change all the components that use headline 6 in your app. It should now look like this. So why go through the trouble of doing this? Like, why go through the trouble of using top-level attributes throughout your styles? Like, what's the reason? And generally, we do this because we want to be able to style your entire app using only these top-level attributes. So say, for instance, your teammate came up to you and said, hey, our brand colors are changing now, so actually we want this maroon color instead of these blues that we had. All you'd have to do is switch some of these top-level color attributes, and your whole app is rethemed. Similarly, if you want a dark theme, or a fake dark theme of sorts, all you'd have to do is change a couple of these other color attributes, and the components should all respond appropriately to that, and you have a different-looking app.
Now we're going to talk a little bit about custom components and how you can use styles in some of your components that you've created. There's really nothing magical about the way our components use theming. It's all just basic Android theming, so you can use it in your components as well. You just have to create a default style, pass that default style attribute into your constructor, and use obtain styled attributes. So let's go through that. Here we have a definition of a theme and some attributes. Here we're creating a default style attribute and setting it in our theme. So we have this my custom view style, and we're setting it to this widget.mycustomViewStyle that we've defined somewhere in our theme. So this will mean that any components that use this myCustomView, or any of these myCustomViews, will use this style by default. You also can create a stylable which holds a few different attributes. And then you just need to use these in the constructor. So here's an example of a constructor for a view. Here, we pass in the default style, which we created previously. And we pass this in here so that it can pick up that default style if nothing else is set. And then we're using obtain styled attributes, and we pass in the stylable that we just created, as well as the default style attribute that was passed into the constructor, and finally, a fallback style that can be used as a last resort for finding attributes. And then you just read those in, and that's basically how our components work. So you can definitely do it yourself as well. And also extend the systems for your use cases, right? Like if you have the need for more attributes in some case, you can definitely add those in. It might be a little bit more work on your part because you'll have to update styles for all of the components that you're using to reference those attributes, since our components that we're writing aren't going to be referencing them. But if you need it, you can definitely do that. Here's an example. It's just like an attribute. Just create it and define it in your style, and then reference it, or define it in your theme, and then reference it in styles or elsewhere. And now a little bit about our process. We've had a few releases. The 1.0 went out and was cut on July 20th, and it's been a little while. But now with the Android X Jetpack refactor finished, we can release more frequently because we're not tied to the Sport library. So we're trying to ramp up our releases, and we finally cut 1.1 Alpha 1 October 31st, and we're definitely trying to do this more frequently, around once a month at least. The 1.1 Alpha had the type theming, color theming, and dark theming that we've talked about in this, plus lots of bug fixes and performance improvements. In the upcoming releases, we're going to have the shape theming, which I talked about. In 1.1 Alpha, the shape theming subsystem exists, but none of the components are actually responding to those themed attributes yet. But with the next release, it should. We also updated some styling for dialogues, bottom sheet, menus, those sorts of things are all coming. And as far as contributing and filing issues, GitHub is where our code is. So if you're interested in taking a look, just go on GitHub. You can take a look at all of our code. It's open source. And also you can check GitHub for instructions on how to submit bug reports. We're trying to figure out what works best. Right now, we're taking bug reports at this issuetracker.google Bugnizer component. But we're looking at different ways to make it more obvious what we're working on and trying to integrate more with the community. And here's a few more resources. Material.io site is great, especially the Android section. Definitely check us out on Discord if you're interested in chatting with us, or are interested in helping us have a PR, an idea for anything, just like come and chat with us. We have a tag on Stack Overflow. So if you have questions about implementation, you can ask something there. We're watching that and we'll respond. And then we have a few code labs. You can find the link to those code labs on this GitHub page. And that's pretty much it. Thanks for coming. We're going to be available for questions and answers at the break that's happening now.
Thank you.
Hi, everyone. Thanks for joining me. My name is Ian Lake. I am a developer on the Android team. And I work on quite a few projects, but most notably the navigation architecture component, as well as fragments, as well as some of our new libraries like the Android X activity artifact and loaders. And today, I want to talk to you about single activity, why, when, and how, and really try and share some of the best practices from the Android team and from the architecture component team on what actually is going on in this world. There's been a lot of questions way back from 2014, 16, and even here in 2018. So we're here today to kind of talk over all of those wonderful things that make up what are activities. So activities are really a component at the Android level. So they're at the same level as content providers, broadcast receivers, and services. And they're registered in your Android manifest, and really they are the UI-facing pieces of your app, right? So when the Android framework goes to start your application from a launcher icon or an app shortcut or what you see when you're doing multi-window, those are all activities, right? So they really are kind of the entry point into your app's UI, right? When the user goes to launch your app, they're launching an activity. And we had a very interesting quote from Diane Hackborn back in 2016 that once we've gotten into this entry point to your UI, we really don't care how you organize the flow inside. Now, this was 2016. And I think it was pretty controversial, I guess, in 2016. Maybe we'll just say it had 77 comments on Google+, all right? So a lot of people were really enthusiastic about this post. But really, like, what does it mean, right? Like, well, what I think it means is that the framework shouldn't care. The framework shouldn't care about your application's architecture, right? It needs to provide the hooks needed for the Android framework to start your application. But you should probably care about the architecture of your app. And that's why you're all here today, and I love having you here. So the biggest problem is that you really don't know what an activity is actually going to do. So what's the default animation for an activity? Well, it depends. It depends on the version of Android, what manufacturer you're on, and even what themes the user has selected, right? So similarly, we had property animations that were added in API 11. And they're much superior to view animations. And the thing is that while these new things become possible on new versions of Android, they're not always applied to everything. And things like activities, they don't support property animations at all, even today. And even if we were to add them in the next version of Android, maybe the letter after P, we wouldn't be able to backport them because they're part of the framework, right? So thinking about all these things, it's like, well, OK, what should an activity be used for, right? Why do we even have activities? They're useful as this entry point. But then beyond that, you're in your realm, right? You're in your realm of what your app needs to do. And you don't necessarily need to rely on activities being the thing that you have to work with. So let's take an example. Here we have some code like this. We're calling start activity. And we have to use activity compat because we want to do a shared element transition, right? So we create our intent. And then we say, oh, we want to have this one element shared. Well, what API does this actually work on? Well, it depends on what you mean by work, right? It technically launches an activity. That's true. But it's only actually going to do a shared element transition on newer devices, API 21+. And really, how many compat shims do we need in our life? It technically works. You're saving some API checks. But really, this isn't the prettiest code to look at. And similarly, are there any hidden gotchas? Right? If you are testing this on the latest version of Android, if you test it on an older version of Android, are you actually going to get the same experience? Well, in this example, I actually ran into this, and I was like, oh, well, things are fading in and out. And it's like, sure, I chose fade, but it turns out you need to exclude things like the status bar and navigation bar, otherwise they'll flicker. And I was like, well, okay, well, that's fun. I wouldn't have ever known that unless I tried it once. And I tried it on a whole bunch of different devices, and it turns out on some devices it's totally fine, and other devices not so much. So there's a lot of little hidden gotchas here that you can't actually control or rely on in your app. Another example where we have multiple activities, right? And really each activity is kind of its own component in your app, right? So if you have 2 activities and you want to share data between them, well, there's not really a scope for that. There is a scope for that, but it's called your application scope. It's the same scope that's shared by services and everything else in your app. But you really want kind of a shared scope that's just within a couple of components. So this is a structure that Android provides, but it's maybe not the one you actually want to use. So what you actually want is you want to build the layering you actually need. So in this case, we can have multiple things, multiple destinations within an activity, right? And share information across each of these destinations by using the activity scope as an actual useful element now. So for example, you could have a shared view element or view model that both destinations talk to. So one destination could put data in, and the other one could observe changes to that data, right? You don't need to work at the application scope level for this to work. So I mentioned this word destination. So what is a destination? Well, really, it's just a subsection of your UI, right? So for most destinations, they're going to take over the majority of your screen, right? Like when you move from one screen to the next screen in your app, it's going to change the vast majority of your screen, right? Maybe you have some global navigation, like a bottom nav, or maybe you have an action bar at the top. But the rest of this is all in a destination. So the subsection of your UI, we have a word for this. It's called a fragment. But a fragment is really just one implementation of this idea of having separate destinations for each screen in your app. And really, this fragment is serving as kind of the view controller, right? The thing that isn't a view itself, but something that owns and changes those views, which are really more about display. Right? So really, the activity, instead of owning all of this business logic and things like that, is really as small as is physically possible, and really only working on the kind of that shared UI that's shared across all destinations. So when we're thinking about this, like if we're moving from this activity world to a destination world, we really want to make that world as easy as possible, right? Otherwise, why would we move? And we focused on kind of 2 things. One was that global UI kind of thing. Like, how can we make that part easy? Right? Like, it's something that every app kind of has the same kind of patterns, and we really don't want that to be something that takes a lot of effort to do. Also, the navigating between destinations, right? That start activity compat thing, can we make that even easier? So we started the navigation architecture component, and we introduced it to you all in I/O this last year in 2018. It is still in alpha right now, and we're looking to fill out all the feature gaps before taking it to 1.0 here soon. But really, what this allows us to do is take a super simple activity like this, just set content view, we'll set an action bar, because that's a thing, right? And we want to make this smart. We want to make this useful, but we still want it to fit on this one code slide. So some of this is we need a nav controller. A nav controller is really the heart of navigation. It's the thing that knows everything about how your app works via a navigation graph. And we can get one. We're using Kotlin here, Kotlin extensions, and call find nav controller. And here we're just giving it the ID of a nav host fragment. The nav host fragment is basically that part of your UI that's going to change whenever you change destinations. We'll also add an app bar configuration. So this is what controls the up action and what needs to happen when you move up from a destination. And how do we hook that up? Well, we have a nice one-liner that just says set up the action bar, gives it a nav controller, and gives it an app bar configuration. Now, because we're using a drawer layout here in our app bar configuration, we also want to open and shut the drawer when you hit the up button. So we'll call navigate up in our support navigate up. And we've set up our whole action bar. Now it changes titles as our destinations change. We're good. If we want to add the navigation view and make sure that we can click on things in our side nav and they go to the right place, that's, again, one line. Because we can do this all because the nav controller knows about our destinations in our app. So then, how do we actually do navigate actions if we're not doing fancy one-liner stuff? Well, we can get a nav controller from basically anywhere. If we're in our activity, we can use find nav controller. It's even easier from a fragment. We can just call find nav controller, and we built the Kotlin extension for this. And similarly, even from a view. Any view that's created by any fragment in your navigation graph can just call find nav controller from a view. So you have this reference to it from basically anywhere. And we really tried to think like, all right, well, if you have arguments to something, how do we make this nice? So we built a Gradle plugin called SafeArgs, which for every destination in your graph, such as this main fragment, we generate a directions object, which has a nice, simple show profile method, which gives you a directions object with type-safe arguments that you define in your navigation graph, and then you just call navigate. And that's it. We'll take care of all of the fragment transaction, all of that sort of stuff for you. So this makes it a lot easier, but we can really go a lot farther with navigation. So has anyone ever built an intent filter before, deep linking in your app? Has anyone enjoyed that experience? Great. One person enjoyed that experience. And really, you have to do this because this is what the Android framework knows, right? It knows I can parse an intent filter and start an activity, right? But in so oftentimes, that's not quite enough. You need to go a little bit farther, right? So what we've done in navigation is for any one of your fragments, any destination in your graph, you can add a deep link. It's a simple one-liner, and you can even add arguments right here, and we'll parse those out even for things like query parameters. We'll parse those out and give you them as arguments to your destination. And then, because no one likes writing intent filters, we'll also generate the intent filters for you by adding a navigation graph. So this was something we actually added to Manifest Merger to kind of generate that for you. So all this layering helps us build nicer APIs. But it also makes it easier to test your application, right? If you're testing at the activity level, all of a sudden that means, OK, well, how do I test that start activity actually did the right intent? And we have to build extra testing frameworks on top of testing frameworks to try and mock out these things. But if we're moving towards more of a single activity model into the navigation controller world, we still want to test all of those things. We want that to be easy to test. So rule number one of testing things at the destination level is don't test at the destination level. It's really the number one thing with testing, right, is making things nice and separate and extracting some of that business logic out of a destination and into something you can test in isolation, right? So example, a view model is a really nice place to put some of your business logic because you can test it in isolation, right? We have a view model provider factory for providing view models where you can just inject things into your view model, test that totally separate from your UI. But that doesn't mean you don't want to test any of your UI stuff at all, right? We have Espresso tests for a reason, right? We want to make sure that all parts of our app work well and are testable. So how can we do this? This Monday, we released Fragment 1.1, the first alpha. And with this became a new artifact called Fragment Testing, which is about like 6 years overdue. And it's really around being able to test your Android X fragments in isolation, right? Separate from an activity, separate from everything else, but being able to test and verify that that fragment is doing the right thing. So super useful for things like espresso tests, where you do want to test that logic, right? Your business logic, separate object, but your UI logic, right? What happens when you click that button is still something that we want to verify is correct. Now, the nice part about this, it's called Fragment Scenario, because it's actually built on a different class called Activity Scenario, which is part of the Android X testing team, and actually the testing team was instrumental in getting Fragment Scenario out there. But the best part about this whole scenario is that it works both on instrumentation tests, tests on your actual device, and on Roboelectric. So you get one test framework that works on both of these. So really exciting opportunity, and something that now you can test with fragments. So what does this look like? So let's say we want to test our profile fragment. Right? We did our directions thing, right? We're passing in a fake user ID here, and we call launch fragment in container. That's it. This one line has both created an empty hosting activity, added the fragment to it, and waited it for it to be resumed. And now it's ready. Like, you can now use this fragment. So if you want to call on fragment and run some code on your fragment and say, like, well, is the fragment in the right state? Great, you can do that. Here, we're just going to check to see if our args are what we think they are. We've passed in a user ID. We can use the other half of safe args using the args class, another generated class, and just say, like, well, is the args user ID actually equal to the user ID we passed in, right? Did we not mess up on all of that sort of stuff? But you could see if you could run any logic, any method on your fragment right from here. Or we just run espresso tests, right? You say, is the username actually equal to the user ID we passed in? Right? When we click the subscribe button, does it actually change the text to subscribed? Right? Does it do its thing? Right? And all we can do this with just that one line of launch fragment and container. For Java users, it'll be fragment scenario, launch and container. We obviously make that a little bit nicer for you guys. But you don't test a fragment in isolation because fragments do talk to other fragments, right? And like, I work on navigation. So there's that other bit of testing of how can we test the links between different destinations, right? Between different fragments. And really, the nice part here that we have, because we're using these higher level components and not something like activity, is that we have a mockable layer, right? One of the things that we found when building navigation is that most companies, once they got to a certain point, and they're like, wow, we should add some testing, and they're like, wow, we can't really test start activity, so they built their own navigator, which just provides a layer to mock out the start activity calls. Well, that layer is handled for you. It's called nav controller. We test nav controller. So now what we can do in our activities is just mock out that nav controller and confirm that, yes, you're calling the right navigate calls. So here we have our profile fragment again, and now it's getting our user ID. And really what we want to test is this on view subscribers button. Right? So you could tell, like, all right, well, we click this, and like, oh my God, it's like doing something complicated in the fragment. How are we going to test this? Here, it's calling navigate, right? Like, how can we make sure that this is actually doing what we want it to do? Well, it's pretty easy. We can do our scenario thing just the same, launch fragment. And now we can just mock out our nav controller. And now you call on fragment, and what we're doing here is actually just creating our own nav controller, right? There's no nav host here, but we can just inject one, right? This is actually what nav host fragment is doing under the covers. It's calling set nav controller on a view and saying, here's my nav controller. But now, what we've done is, from this fragment's point of view, it has a navigation controller. All those find nav controller calls that normally you'd have to inject something in to get your nav controller, now it just works. Like they're in there, right? And now we can just run espresso tests and say, like, click on the View Subscribers button. And the nice part is that because we're using these directions class, we can use them also in our tests. And because they implement equals, we can just do a simple verify and say, verify, did you actually navigate to where we think you're navigating, right? And even if there's a lot of parameters in there, if there's extras and other options in there, we can now just verify, right? And this makes it so much easier to test those interconnections between each destination. So nav controller is kind of a special case because we find a nav controller, right? So many other things aren't a service locator kind of pattern. It's we need to inject in those dependencies. And this is another one of those like 6 years too late kind of a thing. But we're finally working on it. So there's a class in Android P called App Component Factory, which allows you to construct activities, services, broadcast receivers, and services all via dependency injection, right? You get a chance of calling the constructor instead of the system calling your constructor. Same thing here with fragments, where now you can actually do constructor injection into fragments, right? You no longer need to only have a no-args constructor to use fragments. You can use a fragment factory to instantiate your fragments for you. So this is really useful also for cases where your fragment was like casting your activity to something. I know we probably still have a template that does this. We'll fix that. And there's a lot of ways where really we want to inject in all of those external dependencies so we can test, again, in isolation. And Fragment Factory works great with our fragment scenario. So what does this look like? We know how to test a view model, right? It's just an object. You instantiate it. You do the thing. And it has a real method called subscribe, right? But really, we want to test our fragment. And our fragment has an onSubscribe method that calls viewModel.subscribe, right? And it does its thing. How do we get this view model? Well, we can inject the factory itself, inject the view model factory. And here we're using some of the other new stuff in Fragment 1.1, this by view models, another Kotlin property delegate that does all that view model providers of kind of stuff for you. But we now have a fragment that, well, we've injected something, but then we still need to test, like, OK, well, did it actually call subscribe? Right, we're back to the same situation of building testable code. So we can build a navigation activity. This is what it's going to look like in real life, right? We're going to inject our view model factory. And then because code is hard and I wanted to write things on slides, I built a helper class called an initializer fragment factory that basically you just call add initializer for each fragment. And we call that method to construct your fragment rather than use the default no-arg constructor. So a little bit of magic. There's a link here if you want to check it out. We're looking at trying to integrate this more deeply into the actual library itself. But once you've called this fragment factory, now whenever your activity creates a profile fragment, instead of using that no-arg constructor, it's going to use this constructor. It's going to pass in our view model factory. Great. So our activity looks fine, but our test, how does that look? Well, we create a mock of our profile view model, and then we can set up a factory for it. And then, again, kind of use a fragment factory here that, again, does the same type of thing where we're passing in our mock view model factory. And then our scenario looks almost the same. We just add it in and add, instead of just the arguments, also the fragment factory. Great. Now we can do our same thing on view, perform the click, and then verify that, yes, our mocked out view model did the subscribe call. Right? So now we have a testable fragment, a testable view model, and we've injected all of the dependencies into our fragment. Right? We actually have a testable thing. Now, we are looking at some improvements to this API because we want to make this even easier. So in this case, because we know you're constructing a profile fragment, what we want to change this into is actually something that looks like this, where you can say launch and then give it a method saying, oh, like you launch this fragment, and specifically give it the constructed out instance of your fragment. So you don't have to actually know that, oh, it's using a fragment factory under the hood. You can test just one fragment just fine. Now, there are a few cases where you might think, oh, man, maybe I do need multiple activities. And there's got to be reasons to use multiple activities besides just momentum, right? I understand that a lot of apps, if you have multiple activities right now, this isn't actually an easy sell, right? So there are a few cases where even today, we do recommend using multiple activities. Not a lot, though. So what I'd like to say is you don't actually need multiple activities. What you need are multiple tasks. So what are tasks? Tasks are actually the thing that users are actually interacting with. So a task is a stack of activities, and each task has a backstack. So in your overview menu here, each one of these entries isn't just an activity. It's actually a whole task stack, right? So you're only just seeing the topmost activity of that stack, right? So each element here is a stack, right? When you're doing split-screen multi-window, that's two tasks side by side, right? On Chrome OS devices, things that support floating multi-window, each one of these tasks is a window. It's a one-to-one between windows and tasks, right? Not activities and windows, tasks and windows, right? So launching a new task on one of these Chrome OS devices gives you a new window, right? So your app, maybe it doesn't need multiple activities, but maybe it wants multiple windows, right? So this is the case where, yes, you need to use activities under the hood. Each one of these tasks is going to be a separate activity. But you may not use some of the other things, such as a stack of activities in one task. So what does this actually look like? A lot of this is that there are a lot of different ways of saying new task, right? Has anyone looked at all those wonderful launch mode flags and all that fun? Yeah. How many people of you are still sane? OK. Well, I'll say that there were a lot of good flags out there in Android 1. They were great back in Android 1. In 2018, they're maybe not the best thing to use. What you actually want to use is document launch mode. Now, document launch mode was added actually in API 21. So please, like, if you're thinking about pre-API 21 first, what are you doing? And second, probably try and steer away from hacky solutions. Maybe it's just not worth it for those users. But try and avoid things like launch mode flags and task affinity and those type of things, because while the framework does honor those, it maybe doesn't honor them in the way you want them to honor it. They're certainly a very different kind of thing. So what can you actually do with document launch mode? Well, the biggest thing is multitasking, right? If you can have multiple tasks, then you can have multiple windows, right? You got multiple entries in your overview screen. So the first way of really doing multitasking is into existing. Now, into existing basically means whenever I launch this activity, that activity has its own task, right? Every time you launch this activity, it has its own task. But if we already have launched that task, don't create a second and a third copy, right? So this is really useful for things like documents, conversations, things where someone might want to side-by-side compare two different documents, right? If they're copy-pasting from one document to the other, they're not going to exit out of one doc, open one, copy it, and then open the other one, and then copy it into there, right? This is kind of taking that multitasking model that is Android, that is that recent screen, and making it so that your app actually gets to use this. Now, of course, the into existing assumes you have some notion of uniqueness, right? So it does assume that from an intent filter equals kind of point of view, like if you're using the data URI on your activity, that there is some sort of unique ID, right? A conversation ID, a document ID, something to uniquely define that task in and of itself. Now, one great example of this that you can try out on your phones is Google Docs. So Google Docs, when you open a doc, it actually launches it in another task. And if you have multiple docs, you can actually load them up side by side on a phone, two different windows on a Chrome OS device, and it just works, right? Even though it's one app, it can have multiple windows and really allow a different level of multitasking between different things. So another big one is creating new content. So new content's a little different because there's not really any unique ID, right? But you still want that kind of multitasking behavior where you can reference existing material while you're creating something new. All right, so the always flag is very similar to into existing, but it just always creates something new, right? Wow, it's like self-descriptive names. We can do this, guys. And it allows you to do multiple things at once, right? That's great. So one example of this is Gmail. So Gmail actually uses this kind of mode when you create a new email. So this allows you to create a new email and reference your existing email at the same time. It's magic, right? This is the equivalent on mobile of when you do it on the web and it pops up a little mole that's separate from the other one, right? You still need that other material as reference, even when you're creating something new. Of course, on a phone or on a tablet, it looks slightly different. The other case is picture-in-picture. Now, picture-in-picture actually has two entirely separate modes for how you want to approach picture-in-picture. One is using a separate task, right? So this would be a separate activity just for your playback. So this is really common on Android TV devices. For example, Google Play Movies and TV uses this approach so that you can actually put things into picture-in-picture mode and then browse through other movies. So in this mode, it's very much that you have a specific picture-in-picture mode button in your UI. The other mode is using just a single task, one activity, right? You actually don't need anything at all here. And this is the approach that things like Duo and Google Maps use, where your whole task is becoming the picture-in-picture activity, right? So when would you want to choose one or the other? And it's really this case where once I'm in picture-in-picture mode, if they were to click my launcher icon, what would happen? Because the launcher icon always launches the default task, right, of your app. So in Duo's case, where they only have one task, when you launch that Duo from your launcher icon, it's just going to pop open the picture-in-picture. You go from a little tiny picture-in-picture to full screen. Because it doesn't make sense to have multiple conversations going at the same time. You're never going to replace one with the other. You're never going to continue to reference something even though something is already going, right? So that's kind of the differentiator here, where do you want to be able to browse and picture-in-picture at the same time? If you do want to browse, then yes, you're using the Android framework, and therefore they need to position those separately, separate tasks, separate activities. But that's kind of it. The one thing I didn't mention are things like Instant Apps. Now, Instant Apps kind of works at the activity level, right? You call start activity, it downloads your Instant App module. But there's actually some really exciting things that are being worked on by the Play team. I think there was a talk here at Android Dev Summit But a lot of it is around the instant experience for your app bundle, making your whole app instant, and also dynamic feature modules. Now, these are really interesting ways of adding things onto the thing that don't require a specific app architecture to implement. Right? We can actually do more things with this. So for the instant experience, it's adding this distribution instant equals true. And this means that someone can try your entire app, right, your entire base module, all at once, totally instant, right? And this works really well with things like app links. So those deep links that I said you could add to any destination, you can also make them into app links by adding the auto verify equal true. And that means you skip the disambiguation, and when someone launches your deep link on the web, they're going to open up your instant app experience, right? They're going to download that whole base module for you, and your whole navigation graph is already there, ready to go. But this doesn't work if your app is too large, right? So you want to dynamically deliver things that are not used very often or rather big things, right? That's what dynamic feature modules are all about being able to download them on demand. Now, the really interesting part about dynamic feature modules is that you're adding classes, right? You don't need to add activities. You could add just destinations, just a number of fragments, right? So in this case, you can add new destinations on demand. Just because you've built out a XML file for your navigation graph statically, each one of these dynamic feature modules can also add their own navigation graph. So this means that we're not tied to separate activities. We can now actually still use one activity. Now, there's still more to be done here, both on the play side and on the navigation side. But we want to make this really easy for developers to use. So what we want to get to is where you can add something to your navigation graph with just a feature tag, just like you'd add a fragment tag or something like that. And when you navigate to this destination, that's actually going to do all of the downloading and making your feature module available from whatever your split name is. So that's the world we want to get into, where you can use a single activity, where you can use a lot of the useful things like deep linking and navigation without necessarily contorting your app architecture around everything else. So I'd really like to end this with one note. A lot of you have existing apps that have very different kind of experiences, and I'd like to say, do what's right for your app. I think single activity is great. If I was writing a new activity, it would also be single activity. But I realize that going to your PM and be like, hey, let's rip the whole app apart, is sometimes a hard sell. Some of them don't like your current app, so maybe you'll actually get some, yeah, okay, go for it. Really depends on your own experience. If you find yourself contorting your own experience and it's not making sense to you, don't do it, right? If something is working, that's good. Keep it working, right? But if you're finding you're running into issues, you're having inconsistent behavior, right? Or you want to do things like shared view models, maybe that's the time to think about moving towards a single activity structure. So thank you. Q&A, if you're outside. Really appreciate you all coming.
Everyone, the next session in this room will begin in 10 minutes. Thank you.
Hello, and welcome to the last session of Android Dev Summit, or the ultimate session, I think, which is called Get Animated. My name is Nick Butcher. I am a designer and engineer here at Google.
My name is Doris, and I work on the Android UI Toolkit team. I'm responsible for Android Animation API.
And I'm Nicolas Rode. I'm working on the design tools on Android Studio as well as on constraint layout.
John Hofford, working on constraint layout, motion layout, and design tools.
Great, so let's get started. So Android has always had animation APIs. The number of APIs has grown as the system has grown and become kind of more fully featured. There are a variety of different APIs for different situations that have been added over the different API releases, as well as to the new support libraries like Android X. But sometimes we hear that the variety, the range of animation systems can be overwhelming, that you don't know which one to reach for or which is the best for a certain use case. So our goal today is to really give you an overview of the different animation systems, tell you what they're good for, what they might not be good for, and give you the confidence to know which to reach for when you need to achieve something. And we're going to spend a bit of extra time on the new hotness that is motion layout today as well. So let's dive right in. First up is Android's oldest and original animation API, which was Android View Animation. I would urge you to kind of consider it deprecated. Unfortunately, it's not actually app deprecated, as I'll get to in a minute, but maybe just think of it in that way. So this, like I say, an older animation API was kind of runs in a certain phase of the view system. So as everyone knows, most views have like a measure, layout, and a draw. Unfortunately, because the animations only run in the draw pass, it means that we can't do certain things like deferring rendering when we don't need to. And it also leads to certain things where, because the animation is only applied in the draw pass, you don't know maybe what it looks like is somewhere in your layout. Maybe you've animated the button to a certain position. When you try and press it, the view's bounds haven't actually changed. It only exists within the view system, the drawing pass system. So it can lead to a bunch of different problems. Basically, it's been considered deprecated because it has much, much better replacements. It belongs in a museum. Hey. I'd say deprecated, except there are actually, well, one single use case I can think of where you still have to use it. And that is when you're doing window animations. So when you're doing window animations when a new activity launches, then this API only accepts this type of window animation because it existed from API 1. But also because these window animations have to declaratively state all the information to perform the animation. The fact that it runs in the draw pass is useful because it guarantees that the view is already measured when you do this. And that allows it to define certain things like here we're seeing like a Y delta animation, which means 10% of the Y position. So because it's already definitely guaranteed to be measured, this can be useful. The only other place you might need to use it is if you're doing fragment transactions. So here, when you set the animations to run a fragment transaction, you can supply this Android View Animation as an arg, but the API also accepts the newer Android Animator. So I urge you to kind of use the newer one if you can. So that was View Animations. Basically, only really use it for window animations, or if you really, really have to, if you need to rely on that measured size part for a fragment animation. Otherwise, think it's deprecated. Next up, Animator.
All right. Wait, didn't change. Oops. All right. So Nick has just talked about a view animation. Now let's take a look at the animator, the new animator API that was introduced in API 11. So the new animator API is much more versatile than the view animation because it allows you to animate more than just view properties. You can essentially use it to animate any arbitrary property on any object. And then you can even just animate any value, not necessarily associated with any property at all, using the value animator API. And since the introduction of the animator, we've built a bunch of higher-level animation constructs on top of the animator, such as animate vector drawable, animate stateless drawable, transition, and the default item animator in Recycler View. And people always ask me, between animation and animator, which animation API should I use? And the answer is definitely the animator API, because it's just much more capable. And in this section, we're going to look at a few animators. We're going to look at value animators, where you can animate a value. And we're going to look at object animator, which not only animates the value, but also automatically sets that value on a property. We're also going to look at animator set. And then we're also going to take a look at the view property animator. It is not an animator, but it's backed by a value animator. We'll talk a little bit more about that in a minute. And then also, we're going to look at property values holder, which you can use in conjunction with value animator. So here's an interesting animation with a little juggling man. And that can be achieved with the animator drawable, which Nick will talk about in the next section. Or you can use Lottie for it. But now let's look past that. And on top of this little man, there are texts being animated in and out. So in order to achieve that, we can just simply create an object animator to animate the alpha property of this view. Pretty straightforward. Notice how here I'm supplying an alpha string. And that is a bad idea. Because when the property string is being passed to the object animator, what we're going to do is we have to prefix that string with the set and get in order to then use reflection to find the setter and getter in the target objects class. And that's inherently more costly. What we recommend instead is using this view.alpha property object. It is introduced in API 14, along with a bunch of other property objects for other view properties. What happens in this view.alpha is that whenever the animation value gets updated, the set value will be called. And then from there, the set alpha will be called on the view. So that's one level of indirection, much more efficient than reflection. If we take a closer look at this animation, we can see that no text not only animates in, but also it blows up. So there are three things going on, three properties being animated: the alpha, scale x, and scale y. Here's how we can do that with property values holder. We can create 3 property value holders, one for each property, and then we can specify the start value and the end value for each of the property. And once we have all these property values holders defined, we can then set these property values holder on the object animator. So then the object animator can then drive the change of the property values. And one caveat is when you use multiple property value holders on one object animator, you are essentially animating all these properties with the same interpolator using the same duration on the same target object. But a lot of times, when you want to animate scale x and scale y simultaneously, that's exactly what you need. And if you want to define that same object animator in XML with the property values holders, it looks pretty straightforward. Now, if you take a look at the bottom of this animation, there's that button fading in after all the text animations have finished. To coordinate these different animations together, we can just create an animator set, and then with the play method, it would return an animator set builder, and we want to play the fade in after the fade out. So, and then while the text is fading in, we also want to blow it up. So we're going to play the fade in with the scale animation. And then we want to play all the text animations before the button fades in. So that's pretty straightforward API and powerful too. Now, we've seen how we can animate various properties using property values holders in conjunction with the object animator. And if these properties that you're animating happen to be view properties, here's a more straightforward way to animate them. You can just call view.animate. That would create a view property animator. And then there are a bunch of methods for various properties, and then you set an end value for these properties. And then optionally, you can set an interpolator and start. This is the syntax for view property animator. It doesn't get more beautiful and concise than this. And view property is backed by a value animator, it's not an animator. So you can't really coordinate it with the other types of animators. You also can't reverse it or seek it or repeat it. Some people ask me, is view property animator as efficient as object animator? I can assure you it's actually slightly more efficient than object animator. The reason for that is view property animator has been optimized for animating view properties. And as a result, it ensures that for all the view properties that you're animating, there's only one pass of invalidation gets triggered per frame. Whereas if you use object animator to animate various properties, then each property change is going to trigger its own set of invalidation pass. View property animator is more for a fire and forget kind of use case where you just start the animation and just forget about it. Now, you might have seen this animation before in the previous slides. Did you notice that there's 3 little dots animating at the end of the text? And since these 3 little dots are not really a property for the text view, so here we're going to create a value animator to animate the number of dots. We're going to create a value animator of integer type to animate from 0 to 4, and once it gets to 4, it will then wrap around and restart at 0 because there's a repeat count. And with value animator, you almost always want to use an update listener because value animator is just going to animate on its own. It has no impact to anything outside of it. So here, with the update listener, we're going to read the value out of the value animator and use it as the number of dots that we want to show. And then we're going to have a spannable string from the text view. We're going to set a span for we're going to set a transparent foreground color span on this text, rather on the dots that shouldn't be showing, and which with each animation update, we would update the number of dots that should be showing, and then correspondingly change the range to hide the dots that we want to not show. So to recap, when should we use what kind of animator? Object animator is kind of this all-purpose animator that as long as you have a property you want to animate, you can use that. Value animator is for animating a more customized kind of animation where you want to animate this value, and then you want to then use that value to apply to something else in your UI. And the view property animator is best used when you have multiple view properties that you need to animate simultaneously on the same view. And because you can't really coordinate this view property animator with anything else, it's only good for the fire and forget use case. And then property values holder. With property values holder, you can define multiple properties and then animate them using an object animator. The nice thing about property values holder compared to view property animator is that it not only allows you to animate multiple properties simultaneously because it's really being set on the object animator, you can then coordinate that or seek and reverse. So it's more powerful. And then animator set, when you have multiple animations that you want to coordinate, animator set would be a good choice.
Thank you very much. Next up, we've got animated vector drawable. So these are great for doing vector graphic animations like these wonderful little icons you see in the new Google Fit application. Animated vector drawable is actually a very thin wrapper around 2 more powerful things. It basically connects together a vector drawable to one or multiple object animators and runs animations on them. It has a very small, focused API. It basically implements the animatable interface, which is basically just lets you play, pause, and stop the animation. So you can get an animated vector drawable like this and just call start. AVD is great for performance critical kind of vector graphic animation, especially from Nougat onwards, where animated vector drawable was re-implemented in native code and also offloaded to the render thread, which means that even if you're janking the UI thread, and you're not doing that right, that your animation will keep on playing. But it also means that there's just more time on the thread for you to do your code rather than running the animation code. So when to use animated vector drawable? So when you need to animated icons or animated vector graphics. When it needs to be this fire and forget. Because it has that simple API that just start and stop, you can't seek through it. You can't control the progress through it. If you need to do something like that, then I urge you to take a look at something like Lottie or Kyrie, K-Y-R-I-E, drawable. So it's really good for anything which is like performance critical. And that was AVD.
Thank you. Now, physics-based animation. Who doesn't love physics, right? Physics-based animation is perfect for a highly interactive use case where you have lots of gestures going on, and you want to then carry on that momentum of the gesture into your UI to create this sense of continuity. And because when there are a lot of gestures in flight, you could then potentially interrupt the existing ongoing animation. I'm sure you've seen animations where you want the animation to, you want the view to move from one location to the other, and then there's gesture from the users, and then as a result, the ending location would have changed. And in this case, if you use physics-based animation, that would just simply change some physics force, and then as a result, the course correction would be very smooth, and it also gives your app a more realistic look. So here I have an example of this little bubble with my cat's picture on it, and it's in a application overlay window, so it sits on top of other applications. And in this case, that is the beautiful Timely app. My goal is, as I drag this little bubble around, I want it to follow my finger, and then when I let go, it should rest on either side of the screen. So to achieve this, we obviously need to start with an untouched listener, and then we're going to use the velocity tracker to track the movement, and then when there's action down, we need to record a bunch of positions. And in the subsequent move events, we're going to need to calculate how much it has moved, your finger has moved since that down event, and then update the bubble's position accordingly. And then when there's action up, that's where the interesting bits come in. We're going to calculate the velocity from the velocity tracker, and then here for simplification for the demo, we're just going to say when the velocity is greater than 0, we're going to just move to the right side of the screen, otherwise left side. Now that we have the final position where we want the bubble to rest on, we can create a spring animation to animate that bubble's param x prop. That is a custom property, which I'll explain in the next slide. Now we can, before we start the animation, we also want to set the start velocity. And this is critical to ensure that that transition from gesture to the animation is seamless. So this is my custom property. And the whole point of this custom property is really just to associate the animation value with the position of that bubble. Whenever the animation value changes, we get this set value call. We're then going to set that animation value onto the layout params.x, because the view is animating in a application overlay window. And then we're going to have the window manager update view layout to reflect the change. And then similarly, in getValue, we're just going to return the layout params.x.
Back to me. Thank you. Next up is the Transitions API. Now, transitions are really about looking at two different layout states and saying what has changed between them and how do I create an animation to animate those changes. So really, you can think of transitions as like a factory for creating animators based on those two inputs. A while ago, I might have stood up here and talked about how it's great for doing things like this, where you can have two different transition constraint sets and using Transition Manager. But I think that this use case is actually better solved by motion layout, so I wouldn't consider this a good use anymore. It does still have some good things going for it. In particular, this is probably one of my absolute favorite Android APIs. Transition Manager begin delayed transition is like deceptively simple, but you call this, and then you make some changes to the view hierarchy, and magic happens. And that magic is exactly what we just talked about. It looks at those two different states of the UI, works out what's changed, creates an animator, runs those animations. So simple. There's also an overlay where you can control those transitions. The other thing I really love about transitions is that what it does to the shape of your code base. So for example, here's a change where I moved a bunch of code out of the view layer into transitions. So when you're doing animations, sometimes your code can look a bit gnarly like this. So you're doing a lot of view lookup stuff, adding pre-draw listeners, and like poking around at the view hierarchy. By moving it to transitions, we end up moving it to this much more kind of like declarative, composable architecture. So here I'm using some custom transitions I wrote, as well as compose with some of the framework transitions in order to achieve the same behavior, but in this more composable manner. So yes, you might have to write some transitions yourself. Like, so here's one I have to write to do a circular reveal. But that code ends up being much more, I don't know, like nicer to work with and much more focused. And I found it like a really good change to the code base. So transitions, when should you use them? Like for me, there's actually one really strong use case, which is shared element transitions between activities or fragments. So it's pretty much the only thing you can use to achieve this, unless you go like super custom. That is the use case for transitions. There's actually two transitions going on here. There's the shared element, which is between the two activities we see here. And then once the details activity launches, there's actually a window content transition, which is when the window launches or when it exits, run this transition, run these animations on the content. So when you see it come in here, when the view arrives, the rest of the content animates upwards. That's a window content transition. So when should you use Transition API? So shared elements for me is a really, really strong use case. Window content and enter and exit. Also, if you're really looking to like modularize and compose your animation code, then transitions can be really helpful, as well as simple changes using that begin delayed method. So yeah, transitions definitely still have a use case. Motion layout.
All right, so far we've been talking a lot about coding, right? And the nice thing with coding is that it's super powerful. You can do a lot of things. The APIs are really, really complete. On the other hand, it's also quite time-consuming. So, taking my hat on the Android Studio Design Tools team, what can we do to help that? Really, our goal is to make you more productive, let you iterate faster, experiment, and make your life easier, really. So we want to make, particularly for motion, we want to make the motion design a lot more accessible. So one thing that we introduced recently in Constraint Layout 2 is the helpers objects. And in fact, helpers object is something that you've been using if you used Constraint Layout before. That's what we use for guidelines, for barriers, for these kind of tools that are not really part of your view hierarchy in the sense that they don't show up on screen, but they are here to help you create those layouts, so to basically bring additional concepts to make it easier. And in 2.0, we expose them publicly, so you can yourself create helpers just by inheriting the class. And what's great is that it's a way of encapsulating a behavior in code and putting into a helper. We support the use of helpers in Android Studio, so it's very easy to add widgets to those helpers, to have the helpers reference those widgets, and you can think about it as a way of tagging those widgets with a specific behavior. So in the case of animation, that's really nice because you get the code, you had your helper built on top of this code, and we got all the wealth of the Android animation APIs, and you can do stuff like that, right? So for example, circular reveal. Pretty well-known animation. The only thing I really needed to do here is to define this piece of code. And really, what I'm talking about, okay. What I only need to do here is this code that you see on the screen. I'm simply calling the view animation utils create circular reveal. So I'm not reinventing the wheel here. I'm not coming up with my new way of doing circular reveal. But that's the only thing I need to do for my helper. And then in your layout file, you only need to declare that helper and specify the IDs of the widgets you want to apply to. So it makes basically it's a lot easier for you to package blocks of reusable code and use them in your application. So going back to the code stuff. So the other way that we thought about making your life easier, beyond letting you build those reusable bricks, is by moving to a declarative way for animation. So you can think about it as a specification for motion, and we interpret this specification with a motion engine. And on top of that, we are building a graphical motion editor. So it's something we introduced at Google I/O. We are still working on it. We decided to focus those last few months on the library side that implement this motion engine, because we kind of want to make sure that it's right for you and for your needs. But just a quick overview on the current build. It's coming along, and hopefully it will come soon in a Canary version of Android Studio. But essentially, we want to make sure that the concept in the libraries are right before kind of releasing the tool. So that's kind of like the overall approach we have for helping you. So the helpers on one hand, and this motion specification on the other. The thing that's kind of nice, if I look at this in particular, is that you can specify this motion and we'll then take care of it. You don't really have to write code for it. It's really completely declarative. So the one way right now that we implemented this motion spec is through motion layouts. So what is motion layout? It's a view group. So one caveat is that it means you can only animate the children of that view group. And it's a subclass of constraint layout. So if you know constraint layout, it's great. You can directly use motion layout to animate your existing constraint layouts. On the flip side, you do have to know how to use constraint layout. But it does a lot. So we do layout transitions. We interpolate properties as well. We have a really powerful support for touch-driven motion. So it's kind of like taking a little bit of various areas of animation and packaging it into a single place. So roughly speaking, the only thing you have to understand is we are animating between two states. We have a start state and an end state. And we just interpolate between those two things. So in addition to basically supporting layout changes, so essentially if we have two versions of the layout or to go from one to another, we also support custom properties. So for example, if you want to animate colors, and we also support the concept of keyframes. And you can think about keyframe as essentially a modifier on that transform between the start and the end. So to kind of summarize, with motion layout, it allows you to think about your animation, your transition, your motion as a declaration. You just specify what it should do, and we take care of it. It specifically is great when you want to do fine-tuned animation, what we call like bespoke animation, bespoke motion. So where it's very specific what you want to do. It's about like coordinating a bunch of widgets together in a very specific way. And finally, it's really nice as well for the touch-driven motion.
I don't think I need the mic.
Go for it.
Yeah. So I want to just kind of like show you guys a lot of things, and it'll be a little more visual from here on in. So this is where you want to create carefully crafted, custom, coordinated, crazy cool animation. You can do stuff like that. So how did we do that? It's just two chains that change into one chain, and each letter is a view. And then we use a stagger and a color change in a custom attribute. It's fairly simple to build. It took me a few minutes, and it looks cool. And that's kind of what this stuff is all about. So the first thing, you can drive our stuff with touch. Essentially, it will handle swipes. If you flick, it will go across quickly. It understands the velocity and manages that. The next thing to understand is we're starting from 2 constraint sets, but we have keyframes. And in this case here, I'm starting with 2 constraint sets, and I'm not having any keyframes. And you see how it crosses right there. Right there, they overlap. So what you do is you add some key position keyframes, and you accelerate in the X. You finish the X part of the motion halfway through. And that gives you a kind of smooth, you've seen this. It's your settings menu. So on the more extreme end of what we can do with keyframes are key cycles. And here you can see a bunch of different kind of effects that we can do. Essentially, anything that's oscillating, it's shaking, or it's bouncing around, you don't want to actually go and build out complex paths with keyframes. This solves it. And then in Alpha 2, we introduced time cycles. And this is a kind of a crazy animation that you can do with it. Of course, this is way too over the top, and please don't use this in product. So let's get into how to use it.
Right. So give me that. Thank you. So first of all, there is a bunch of documentation that we created. So I'm going to pass quickly, but please look at those articles. There's also a GitHub with examples, so look at that. But one thing you may ask yourself is that, okay, this is all great, but how do I use that in my application? Do I have to restart everything from scratch? Not quite. Like, this is an example here where you have a collapsible toolbar in a coordinator layout, and to do these kind of things with the normal collapsible toolbar, it's a bit annoying. You have to do it in code, etc., etc. You can simply use a motion layout instead. So you still use coordinator layout. You don't really change anything else in your code, but the collapsible toolbar becomes a motion layout and take all the advantages of it. Similarly, if you have a drawer layout, you don't have to use the menu class. You can use a motion layout for it and do anything crazy. Same thing for view pager. You can easily plug motion layout into it. The last example is interesting. It really looks like coordinator layout, but actually, this is pure motion layout. And what's nice about it is that it actually is 2 motion layouts nested. And we have one for the collapsible toolbar. It's in fact, it's exactly the same one I used before for the coordinator layout example. And it's simply nested into an outer motion layout. And what's really nice is that in order to specify how this overall screen behaves, I just need to create those 2 states, the start and the end. You see that in the end, I bring up a fab, and I simply make the motion layout that's for the toolbar a little smaller. And basically, we take care of all of it. So to summarize for the current state, we're still working on the graphical editor. But for the library, we released it already at Google I/O. And since then, we did an alpha 2 with a few more properties. And even though it's in alpha, it's actually built upon constraint layout 1.1. So it's actually pretty stable. And in fact, because it's pretty stable, quite a few people started to build stuff with it. And we'll go through some examples just to give you a little taste of what you can do with motion layout.
So I looked on the Twitter a lot. I checked motion layout on Twitter all the time. And I thought I would just share a few interesting animations that people have published. So most of these you can actually find in GitHubs. These people publish them as videos, and I've asked all of them to sort of show them. This guy has been doing quite a few pieces of work with it. It's kind of interesting to see what he did here.
And this one is particularly interesting. By the way, you did not maybe notice in the previous one, there was an arc motion, which is very nice, something we did in Alpha 2. But in this particular example, what's nice is that it's kind of like a view pager. He did it in motion layout, but he also added a way to drive it from code. And that's a very interesting future avenue for us where we're going to explore it a little bit. How can you, in code, reuse some of this previously defined behavior?
So another one by him. The interesting thing here, it's sort of mixing what is a normal recycler view and then a sort of a reveal detail view. But it's an interesting motion layout-based animation between the two of them.
And you notice that it's super easy to come up with your own ways of doing this kind of transitions. You're not limited anymore.
Yeah. This guy implemented a material design animation spec, but just using motion layout and a custom view that he built. It was quite a nice piece of work, actually. One of the things I liked about this one is it's so original. I mean, you see a view pages, yeah, okay, this is like taking a whole new twist on it, or spin on it, actually. But you can see it's original, and that's the beauty of motion layout. You can sort of explore your own creativity or your team's creativity with what they like and what they do. This one is interesting because it's kind of like a typical coordinator layout stuff, but you see it's transparent, and there's some special effects going on with things fading in as it's collapsing. It sort of produces a unique, custom view of the whole thing. And this is our Chris Baines. And he did a very interesting one, and it's a whole app. It's actually, all the codes involved is out there. And it is very custom. So let's take a little closer look at it.
So what's great with it is this is the type of motion that would be kind of annoying to build purely by code, because there's a lot of subtle coordination across so many elements. The text is fading, that poster is actually rotating, but actually matching the angle of the cut. So that's what we mean when we are talking about bespoke motion or very fine-tuned, custom crafted motion. This is the type of example that we hope will encourage you to build.
As a small sneak peek at what we have in Alpha 3, it'll support multiple states and allow you to interact with the multiple states purely from touch. So this is one single motion layout, but in fact, it's handling transitions between 3 transitions, from a blank page to swiping up at the bottom, to swiping a little bit, to swiping more. It's all one page, one motion layout, and it can produce a fairly sophisticated custom view, and I sort of made it look like a dialer.
Yeah, and this entire behavior, this touch behavior, 0 code from your end. It's all declarative.
Pretty awesome. Cool. So today, well, hopefully, we've given you a guided tour through this variety of animation APIs that does exist on the platform. And our goal was really to make you more familiar with what they're good at and what they're not so good at. So I'm going to try and summarize that as a takeaway for you here so that you are confident in picking the right one at the right time. For complex coordinated layout, and especially for that nice handoff between gesture and animation, then really, really, really do check out Motion Layout. Next up, if you need to build interruptible animations, or again, do gesture to animation with that velocity tracking, then look at the physics layout system. If you need to do shared element transitions or window content transitions in your application, then Transitions is the API for you. And if you need to do vector graphic animations, then check out Animated Vector Drawable. If you need to do window animations, and only if you need to do window animations, then the original SDK1 view animation system should be used. It's your only choice. If you need to animate properties of views, and it's supported by it, then look at the View Property Animator. If you need to do custom view animation or some custom thing driven just by an animation pulse, then look at the Value Animator. And lastly, else, use Object Animator. Object Animator is your go-to default for general purpose animation. So hopefully that's made it a bit clearer. So next time you have to build something, you won't be paralyzed by choice of the different animation APIs. So thank you very much for joining us, and we'll be outside for questions or contact us online. Thanks very much.
Hello. So now it's time for a completely different session that'll last about 2 minutes long. We're just closing out the day here. I was personally curious whether you liked it or not. How many people like the Dev Summit? Hey. How many people didn't like the Dev Summit? And what are you doing here still at the end of the second day? All right, so maybe it works. That'd be cool. I think the people from my team and other teams at Google also liked what happened here this week. Both the community aspect, hearing from you and being able to talk to you much more, as well as being able to communicate a bunch of the content and information that we did. So hopefully we will hold this again. Hopefully it'll be a little less than 3 years next time. We just have to convince the people that actually write the checks there. So some of the favorite things that you saw this week, just shout out. What'd you see? Don't make it awkward. Motion layout, all right. What else? Preferences, nice, all right. Yeah, new little bit of thing coming out of the toolkit area. What else? Live data, yes, very cool. Low latency audio, yes, and live coding C++ in a 5-minute lightning talk. That was fun. What else? App bundles, nice, yes. More details on how to do that stuff. Cool. Kotlin native, all right. Very interesting coming online. What else? I heard Pairside Chat, which doesn't make any sense at all. Fireside, oh, you know, I've heard of that one. Yeah, Fireside Chat was fun. Actually, that was really fun today. People like the chat? Is that good? Awesome. Yeah, good questions, good discussion. I like that. There is everything available now, almost online already. Day 1 is already posted to YouTube. I heard earlier that day 2 is going to be live as early as like 8 or 9 o'clock tonight. So go back to your hotels or your homes, and instead of going to sleep, watch all of the content that you didn't get to catch this week. Highly encourage you to do that. Also, you will be getting a survey. Maybe it's even in your inbox right now. Please do fill it out. It's very important for us to know what landed, what didn't, what we can do better. We do actually read this stuff and pay very close attention to it, because if we're not doing something that is serving you, it's kind of pointless, right? So tell us what worked, tell us what didn't, tell us what we can improve, and we will do those things for you, because you are the reason that we're doing this. Let's see, anything else? I think that's about it. I am looking forward to doing another one of these. We just have to get them to do that, so hopefully we'll see you in 2021. In the meantime, in case you missed everything that happened in the last 2 days, we tried to capture it in 90 seconds.
Welcome to the 2018 Android Developer Summit. This is an event for developers by developers.
With over 2 billion devices, 3/4 of a trillion apps downloaded every year, Android's developer community is growing hugely. We saw it more than double just in the past few years.
So the Android App Bundle makes it much simpler. With no additional developer work needed, the App Bundle now makes apps an average of 8% smaller to download for M+ devices.
We simply could not do this without you, so thank you.
As Dave just said, thank you. Thanks for coming.